Check, check, check. Online students, can you hear me clearly? Online students, can you hear me clearly? Students in the YouTube live and in the Zoom meeting. Okay. Okay. And in the students in the YouTube live, can you hear me clearly? Please confirm with a message. Okay. Last rows, can you hear me clearly? Last rows? Okay. So let's start the class. So today our target is today we are gonna start measuring instruments lesson. Okay. So to start with again, I think I hope you know about the 6:30, 7:30 session. I mentioned that last week, right? We are doing an additional session today from 6:30 to 7:30, not mandatory, okay? Not mandatory. I mean, there's no, like, you don't have to join that for sure. I mean, like, it's not, I can tell that it's not necessary, but it's not mandatory. That means you can leave the session or watch the recording later or do anything because it doesn't affect your like A pass a lot. Okay, I'll talk about that later. You didn't receive the tute. Only provide the tutes. Tutes are available in the resources section, in the groups, and in the YouTube live also there's a drive link, and in the Zoom chat there's a drive link with tutes. And again, we have delivered almost all the tutes. Okay, we have delivered almost all the tutes, and some students haven't received that. I mean, you haven't checked the group, so it's not the institute that you pay. They are not handling the tute delivery. We are handling the tute delivery. I mean, usually institute usually handle the tute delivery. So some students have mentioned like message the institute asking the tutes. No, they are not handling the tute delivery. We are handling. I personally handle tute delivery because when the institute do that, it always get delayed. That's why. Okay. So ideally, it's a service provided by the institute, but we are not doing that. We are doing it by ourselves. So our staff is handling tute delivery. So you should always message to get the tutes. You should always message the number that we give for tute delivery. Okay, not the institute. Okay, because we are the one who are handling tute delivery. Okay, so today also I'll give you a number to get the tutes delivered. Okay. Uh, Vectors not necessarily in this lesson. Okay, but so now can you hear me clearly, live students? I should. Okay. So then let's start today's lesson. Today's lesson is about measuring instruments. Okay. I'll talk about other sessions and all later. Okay. I'll talk about other sessions and all later about the 6:30, 7:30 session and all. Did you receive an additional tute Olympiad? So in that tute, like 90% of those questions we did before. Okay. Questions already given to you guys, because today in the 6:30, 7:30 session, we should first clarify the issues we had previously. We didn't even discuss that first day tute. We didn't discuss that, right? So today the main target is finishing a lot of content from previous weeks, okay, in the 6:30, 7:30 session. That's why you have a lot of questions in the Olympiad questions tute. That's why you have a lot of questions from the previous weeks. But towards the end of that tute, okay, towards the end of that tute, you can find some other new questions, okay, some motion graphs questions and all. You can find some new questions there, okay, some motion graphs questions, some additional motion equations questions, one or two units and dimensions questions, okay. If you have time, you can try them, okay. So let's start the lesson. I'll talk about all other sessions later. And all the new plans. For now, let's start the lesson. So talking about like any physical quantity, talking about any physical quantity, a physical quantity consists of two parts, okay? A physical quantity consists of two parts. One is the numerical value, and the other one is the unit, okay? Any physical quantity consists of two parts. One is the numerical value and the other one is the unit, okay? This is the numerical value and the unit. So until now we were discussing about this unit, okay? Until now we were discussing about this unit, and now we have to discuss about the numerical value and how to get that, okay? Numerical value and how to get that. Then when talking about this numerical value, we need to get measurements for this. So getting these measurements, getting the numerical value or getting these measurements, for that we have to use measuring instruments, okay? For that we have to use measuring instruments. So when it comes to measuring instruments, okay? When it comes to measuring instruments, when we talk about measuring instruments, one of the main things that we discuss about measuring instruments, or one of the key features of any measuring instrument is the least count, okay? It is the least count of a measuring instrument, okay? Least count of a measuring instrument, okay? Least count of a measuring instrument, okay? What is the least count of a measuring instrument? What is the meaning of the least count of a measuring instrument? Least count is the smallest measurement that a measuring instrument can get, okay? Least count is the smallest measurement that a measuring instrument can get, okay? That means if you have a meter ruler, you know that there are smaller lines like this, much lengthy lines like this. But anyways, what is the smallest gap that you can measure from a meter ruler? Smallest gap that you can measure from a meter ruler is the 1 millimeter gap, okay? The smallest gap that you can get using a meter ruler is the 1 millimeter gap, okay? You can measure you can measure 1 millimeter units, okay? So the least count of a meter ruler is going to be 1 millimeter, okay? Least count of a meter ruler is 1 millimeter. And you have seen, like, take a stopwatch. There are values like this. So the smallest value is sometimes 1 second, sometimes 0.1 seconds. So there are instruments with different gaps, okay? There are instruments with different gaps, okay? For some instruments, you have a smallest gap of 1 second. For some instruments, you have a smallest gap of 0.1 seconds, okay? Clear? So this is the least count of a stopwatch, okay? Then take, you have seen a lot of electronic measuring devices. So take an electronic balance for an example. When you place something, okay, if this electronic balance shows 4.001 grams, if it shows 4.001 grams, then the meaning of that is it can measure up to this smallest value, okay? The meaning of that is it can measure up to this smallest value. Clear? That means its least count is 0.001 grams, okay? Clear? Its least count is going to be, its least count is then 0.001 grams, okay? That means it can measure up to this decimal point, okay? It can measure up to this decimal point. So this is the least count of this instrument, okay? So in an electronic balance like this, if you place exactly 4 grams, okay, it will still show not 4 grams like this. It will show 4.000 grams, okay. In an electronic balance like this, if you place exactly 4 grams, it will never show the value 4. It will show 4.000. Why? What is the reason? 4 grams and 4.000 grams are different, okay? When it comes to measurements, 4 grams and 4.000 grams are two different things when it comes to measurements. Why? What is the reason? What is the reason? The reason is like there can be an electronic balance that can only measure 1 gram, 2 grams, 3 grams, 4 grams. There can be measuring instruments like that. They can measure only 1 gram, a gap of 1 gram, okay. There can be a measuring instrument that can measure only 1 gram, after that 2 grams, after that 3 grams, after that 4 grams. If that measuring instrument shows you 4 grams, the meaning of it is what? What is the meaning of that? That means it is 4 grams, but it can be 4.1. It can be 4.2. It can be 4.3. It can be 4.5. It can be 4.50321 or anything. I don't know. I can measure only up to 1 gram unit. Okay. If there's a measuring instrument that can only measure grams, 1 gram, 2 gram, 3 gram, 4 gram. So if it shows you 4 gram, the meaning of that is not, it doesn't mean that the measurement is exactly 4 grams. It just means that the measurement can be around 4 grams, but that's the best I can do. Okay. If a measuring instrument shows you 4.000, the meaning of that is I can measure up to 3 decimal points. And I know for sure that it is 4 grams until 3 decimal points. Clear? If a measuring instrument shows you 4.000, the meaning of that statement is value is 4, but it's not just 4. I know that for sure until 3 decimal points. Until 3 decimal points, I can confirm that it's 4. Clear? 4.000. If a measuring instrument shows you 4, that means it is 4. But I don't know about the upcoming decimal points. It can be 4.1. I don't know. Okay? Clear? So these are entirely different when it comes to measurements. Okay? These are entirely different when it comes to measurements. You have to be careful. Okay? And I mean, at the end of the day, none of the measurements in the world are accurate. Okay? None of the measurements in the world are accurate. Why? There can be a measuring instrument that can measure up to 10 decimal points. But you don't know what would happen in the 11th decimal point, right? There can be a measuring instrument that can measure up to 1000 decimal points. Clear? But you don't know what would happen at the 10,000th decimal point, right? Clear? You don't know that for sure. Clear? You don't know that for sure. So we never get accurate measurements in this world. Okay? Clear? We never get accurate measurements. It cannot be done. Okay? It cannot be done. Okay? We only get relatively correct measurements. Okay? We only get relatively correct measurements. Measurement can be correct to a large extent, but still there can be 10,000th decimal point that goes wrong, that the measuring instrument can't handle. Okay? Clear? So all the measuring instruments in the world are doing their best. They are not giving an accurate result. Okay. So with that statement, you should understand that when it comes to measurements, there's always what? There's always an error. There's always an error. Okay. There's always an error. When it comes to measuring instrument, there's always an error. Okay. You have practicals these days, right? Today, yes or no? Today, tomorrow? No? Done with the practicals? No, still have practicals. Today also there are practicals going? Really? What is the subject? Drama. Okay. You should have done literature. Okay. And art people, do you have practicals? I don't know. No, right? You just have to draw something on the spot, right? Okay. Let's move forward. So now we should understand that whenever there's a measurement, something that cannot be avoided, these errors, right? We can never get rid of errors. So what we should do is, so now we know that there are inbuilt errors in any measurement. So what we should do is, we should understand errors. If we can get rid of errors, it's good, but it's impossible. So what we can do is, we can understand errors. And we can quantify errors. Okay, this can be the value of the error. We should be able to understand errors and quantify errors. Okay. So when it comes to understanding and quantifying errors, there are two main types of errors. Okay. There are two main types of errors. First one is systematic errors. What is the meaning of that? Systematic errors. Let's write the note later, okay? Everything is included in the tune, but we have to write the short note. Let's write that later. And random errors. There are systematic errors and random errors. Pay attention. What are these systematic errors and random errors? What are systematic errors and random errors? Systematic errors are the errors that you know the exact value, or we can tell the errors that we can exactly quantify. We can tell the value. For an example, if you have used the stopwatch at the lab, the analog stopwatch, okay, the analog stopwatch you have in the lab, okay, after a while, its coil gets old and it never returns to zero, okay? It never returns to zero. You press the reset button, it never returns to zero. It will stop somewhere like this when you press the reset button. Okay, it will stop somewhere like this when you press the reset button. It never returns to zero. This is a systematic error. Why? There's an error. Definitely when you now when you measure something, there will be an error. But you know the value, right? You know the value of the error. Clear? You know that if it is starting at 1 second, okay? If it is starting at 1 second, for sure you know that your measurement is 1 second off, so you can later add or subtract, right? Okay, you can later add or subtract. That means when a person run, okay, you use the stopwatch, okay, you use the stopwatch and it shows 5 seconds. And you know that it's actually 4 seconds, right? But you know that it starts at 1. Clear? So this here, in a scenario like this, we know the error for sure, okay? We know the exact value of the error. Clear? This we call a zero error, okay? If you have error at the beginning, we call it a zero error. Later we'll discuss about that. Then again, sometimes there are thermometers. Sometimes there are thermometers due to different reasons. Due to if the glass tube of the thermometer breaks a bit, the pressure inside the tube changes. So sometimes it always shows 1 Celsius off. Okay. Sometimes it always show 1 Celsius off. Okay. 1 or 2 Celsius off. Okay. Sometimes for a exact change of 2 Celsius, it only shows a change of 1 Celsius. Sometimes different issues like this happens in thermometers. Okay. Clear? Sometimes it always shows an additional 1 Celsius. Okay. Sometimes it shows half of the correct temperature. But when I tell an additional 1 Celsius or half of the correct temperature, in that statement you know the exact error, right? In that statement you know the exact error, so you don't have to worry. Okay. You know the exact error, so you don't have to worry. Why? When you know the error, you can later do the correction, right? Clear? So systematic errors are not a huge problem. Okay. And even sometimes there may be a meter ruler. For sure, you know that it's there's a 1 millimeter or 2 millimeter difference everywhere. So like that, you know the exact error. Clear? So these are systematic errors, and systematic errors you can definitely solve. How? One thing is you first calculate the error properly because you know the error. Then later do the correction. Or you just throw the measuring instrument and buy a new one. Okay? Still a still a kind of correction, right? You throw the measuring instrument and buy a good one. Okay? See? So like that, there's a plenty of ways that you can get rid of systematic errors. Okay? There's a plenty of ways that you can get rid of systematic errors. But now comes the real problem, that is the random error. Random error. What is a random error? The word speaks for itself. It's random. You can't quantify it. You can't quantify it. Okay? That means you get the best stopwatch you can buy in the world. Okay? You get the best stopwatch in the world. Now you have to time a person running 100 meters. Okay? Now the person starts running, you press the stopwatch, and when the person cross the pass mark, you again press the stopwatch. Now when the person pass the pass mark, it takes a small time for any person to see something and for the brain to understand it, send signals to your hand and press the stopwatch. Okay? We call that the reaction time of a person. Okay? We call that the reaction time of a person. You see something, you understand it, you press the stopwatch. Clear? We call that what? We call that the reaction time of the stopwatch of the person. So now, this is very random. Why? 10 people would have 10 different reaction times, and the problem is even the same person will have different reaction times. Okay? Clear? Same person will have different reaction times. Okay? It can be a difference of 1 microsecond. Still microsecond is error, right? 1 microsecond is still a error, right? Clear? Different people have different reaction times, and the same person would have different reaction times. So the error is entirely random. Okay? Error is entirely random. Clear? So you can't quantify the error, you can't tell the value, so you can't correct that. Okay? Clear? You can't correct that. There can be multiple errors like this. Like what? Assume that you have to measure the diameter. Assume that you have to measure the diameter of a wire, you have to measure the diameter of a wire. Okay. Now you get the best measuring instrument that to measure the diameter. But you measure the diameter here, you get one value. You measure the diameter here, you get another value. You measure the diameter here, you get another value. You measure the diameter here, another value. That means the wire is not uniform. Wire is not uniform. Okay? Clear? I mean, whatever the wire they manufacture, they are not perfect, right? So the wire is not uniform. So how can you get rid of this issue? I mean, you can't get rid of the wire and get a good wire. Why? Then it's not that wire. Okay? You were supposed to measure the diameter of that wire. So buying a new wire is not option, right? The task given to you was to measure that wire. So you can't buy a new good wire, right? You have to do something with that wire. Okay? Clear? So if the measurement is not uniform, what can you do, right? Clear? If the diameter is not uniform, what can you do? You buy the best measuring instrument in the world. So better the measuring instrument, the problem will get worse, right? Why? Then you see the change a lot, right? Okay? Now you can see the difference clearly. Okay? If the measuring instrument is not that good, still you can do something because you can't see the error. Okay? You buy the best measuring instrument, then you see the perfect error. Okay? Okay? So I mean you can't get rid of this wire. So it's a random error. Okay? Random error. There's no way of quantifying the error. Okay? Clear? You can't tell that this diameter is correct and this is the error. Why? I mean, how can you choose the correct diameter of the wire, right? Clear? So these are entirely random. You need to measure the thickness of a A4 sheet. You measure thickness at different points. You get thousands of answers, okay? You get thousands of answers. Clear? Again a problem. Clear? Again a problem. You get different thickness values at different points. Clear? Okay? So these are problems. Clear? Okay? So these we call random errors. How can we get rid of random errors? We discussed one method last week. What is that? Draw a graph. Why? When you get measurements, due to randomness, they go a bit up or down. Now when you draw a line like this, okay? When you draw a line like this, okay? It represents all the measurements but give a better mean value, right? When you draw a graph for a bunch of measurements, it represents all the points but is not biased towards any measurement. It's giving you a better mean value, right? So last week we discussed about this, right? Drawing a graph would be a solution for random errors, right? Again, for a scenario like this, what is the best solution? Measure diameter 1, 2, 3, 4 and get the mean value. There's no other way, right? You just measure the diameter at 4 or 5 or 6 points and get the mean value. Clear? You measure the diameter at a bunch of points and get the mean value. So here, I mean, this will give you a better diameter that represents the whole wire, right? It's not the correct diameter because there is no correct diameter, okay? There is no correct diameter because the wire is changing itself, okay? So the solution you have is you get a diameter, a mean value. You get a mean value that represents the whole wire, okay? Clear? There's no other way out, okay? So we call this getting the average value, okay? This is getting the average value. So now So these are the types of errors, okay? These are the types of errors. So the next one, pay attention. Next one, let's finish this part and start writing the short note. So the next one is error analysis. Error analysis. Error analysis means we mention the error, okay? Error analysis means we mention the error. That means we mention the error means we mention the possible error or we quantify the error, okay? We quantify the error. Under that topic, okay, the first method of quantifying the error is the absolute error. The absolute error. What is the absolute error? Absolute error means you just show the value of the measurement as the reading plus or minus the error. And in this case, error equals half of the least count of the instrument. In this case, error equals what? Half of the least count of the instrument, okay? Half of the least count of the instrument. That means, for an example, take a meter ruler. So, least count of a meter ruler is 1 millimeter. Clear? So, in this case, the absolute error would be least count 1 millimeter divided by 2, which means 0.5 millimeters. 0.5 millimeters. Clear? Now assume that you get a reading of 30 millimeters. Then you write the value like this. 30 millimeters plus or minus 0.5 millimeters. 30 millimeters plus or minus 0.5 millimeters. This becomes the value, okay? So this we tell that we writing the value including the error, okay? Including the absolute error. Clear? So why half of the least count? Why half of the least count is considered as the absolute error? I mean, we don't have to know the reasons. These are just rules. But a somewhat correct reason is you take a meter ruler and you have readings like this, okay? And whatever the thing you are measuring, this is 4 millimeter line, or this is 30 millimeter line, this is 31 millimeter line. Whatever the thing you are measuring, it falls here. Okay? Now you can never tell it looks like 30.5. Okay, you can never tell that it looks like 30.5. Why? There's a rule. If it has millimeter points, you have to write it in millimeters, okay? You have to choose whether it's 30 or 31. You can never tell that it looks like 30.5. Why? Then another person would tell that it looks like 30.45. Then there is no then different people would write different measurements using the same measuring instrument. Okay? We can't do science like that, right? Clear? Okay? In science, things could be certain when it comes to measurements, okay? So the measurement can be wrong, okay? Measurement can be incorrect, but still, everyone should write the same answer, right? That's what we expect. Clear? So if it falls here, you can't tell it looks like 30.55. No. you either have to choose 30 or 31. Okay, you have to write the measurement as 30 or 31. Okay, so when a person decides here, the maximum decision the person may have to take, or the maximum uncertainty a person would have, would be half of the least count, right? Maximum uncertainty a person would face would be half of the least count, right? Clear? If it falls exactly at the middle, okay? If it falls exactly at the middle, so the person have to choose either 30 or 31, right? Clear? So there's a possibility of 0.5 millimeter error, right? Clear? The person have to choose between 30 and 31, so there's a possibility of 0.5 millimeter error, right? I mean, you want, if it is like this, 30, 31, and if the object is like this, you won't assume that it is 31, right? Clear? You would choose 30, right? Clear? So if it falls exactly at the middle only, you will have to choose between 30 and 31, right? Then definitely there's an error of half of the least count, right? Clear? So the meaning of this is the exact value we don't know. It looked like 30, okay? Clear? But it could be what? It could be in the region from 29.5 to 30.5. Okay? Clear? Got the idea? It can be in the region from 29.5 to 30.5. Why? I mean, if it was here, I can tell that it is between 30 or 30 point. Pay attention. We don't have to write like this. Why? If it was here, I know that it is between 30 and 30.5, right? Why do we write plus or minus? Why do we write plus or minus? I mean, the person who read the measurement won't be there. I mean, when the measurement is taken, right? One person can get the measurement and another person can later use the measurement. Clear? So if that person has written 30, if someone who took the measurement has written 30, that means the person who took the measurement, okay, the person who took the measurement could have considered this as 30 or this as 30, right? Clear? So the person who, it's a 29. So the person who's got the idea? One person is taking the measurement, later another person is using the measurement. So the person who's using the measurement don't see the scenario, right? The person who's using the measurement don't see the scenario. So if it is written as 30, it can be, it looked like this, then the person who wrote the measurement wrote it as 30. Or it looked like this, then the person who wrote the measurement wrote it as 30. There's a possibility, right? There's a possibility to the measurement to fall in this region, right? Clear? That's why we write 30 plus or minus 0.5. Clear? That's why we write 30 plus or minus 0.5. Clear? It is 30, but we don't know what the scenario when they were taking the measurement, right? Clear? It may have looked like this, and they may have written 30, or it may have looked like this, and they may have written 30. Clear? There are two possibilities. Okay. And the next one. So this is the absolute error. This is the absolute error. But absolute error, yes, it gives you a lot of information about the measurement, the possible error and everything. But the absolute error never talks about the quality of the measurement. Pay attention. The absolute error never talks about the quality of the measurement. What is the meaning of the quality of the measurement? What is the meaning of the quality of the measurement? Quality of the measurement means, assume that when you are measuring, you measure 1 kilometer, okay? You measure 1 kilometer using a certain measuring instrument, okay? You measure 1 kilometer using a certain measuring instrument. The error in that measurement is 2 centimeters. Clear? Pay attention. Error in that measurement is 2 centimeters. It's okay now. Okay. It's good that you are focusing. Okay. So the next thing, you measure 1 millimeter, or you measure an object or a leaf or something of length of 3 millimeters. Okay. And the error in that measurement is in the range of 1 millimeter. Clear? So for sure, here we have a larger error than this, right? I mean, when the changeover turns from the main to generator, power goes out. When power goes from the generator to the mains again, that means when we are receiving power from the grid again power goes. Okay, anyways, pay attention. So this is 1 kilometer, and in the YouTube live, students in the YouTube live, Mali, check both the Zoom and the YouTube live. Okay, so pay attention. So for 1 kilometers, I mean, definitely this error is bad. Okay, this error is worse than this, right? 1 millimeter is a very small error, but 2 centimeter is a large error, right? 1 millimeter is a very small error, but 2 centimeter is a large error. Okay? Pay attention. But which measurement has a higher quality? Which measurement has a higher quality? Definitely this one, right? Definitely 1 kilometer. Why? Definitely 1 kilometer. Why? What is the reason? Projectors. Projectors. Definitely 1 kilometer. Why? This is a very large measurement. 1 kilometer is a very large measurement. And the 2 centimeter error is almost negligible. Clear? 1 kilometer is a very large measurement, and 2 centimeter is the error is the 2 centimeter error is really small. Clear? Got the idea? But when you are measuring 3 millimeters, pay attention. When you are measuring 3 millimeters, a 1 millimeter error is really large, right? Mali, Ajay, Mali, projectors. Okay. Thank you. So, when you are measuring 3 millimeters, a 1 millimeter error is really large, right? Clear? So, the quality of measurement is higher in this scenario. Got the idea? Clear? So, it's not the size of the error that matters. What matters is the size of the error compared to the measurement. Clear? Size of the error compared to the measurement. Got the idea? It's not the size of the error that matters. It's the size of the error compared to the measurement. Clear? So here, this measurement is better. Why? When you are measuring 1 kilometer, an error of 2 centimeter, you can forget. But when you are measuring 3 millimeters, an error of 1 millimeter, you can never take this as an accurate measurement, right? Clear? Because the measurement is 3 millimeter, it could be 4 or 2, right? Okay? So the error is too large, right? So the thing is, we have to consider this when evaluating errors, and measurements. So as a result, we introduce two ways of evaluating that. One is the fractional error. 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 That's what I mentioned. Okay. Okay, students online, you can see us, right? One is the fractional error and the other one is percentage error. Percentage error. Pay attention, one is the fractional error and the other one is the percentage error. What is fractional error? Fractional error means, pay attention, stop talking. Fractional error is error over measurement or error over reading. Error over reading or the error over measurement. Okay. Error over reading or error over measurement. Clear? That means, pay attention, stop talking. We evaluate the error compared to the measurement. Clear? We evaluate the error compared to the measurement. So it's better if we can write, it's okay, let's keep it as reading. Okay. And the percentage error is, percentage error means you just get the fractional error. You just get the fractional error. And get the 100%. Clear? That means you present the error as a percentage. So pay attention. Fractional error is the error compared to the reading as a fraction. Percentage error is error compared to the reading as a percentage. Clear? So in these two scenarios, error is considered as, directly the least count. So in these two scenarios, in the fractional error and percentage error, we directly consider the least count as the error. So you have to remember, if they ask the absolute error, you write half of the least count. If they ask for the fractional error or percentage error, error is directly the least count, and you put it here, put the reading here, get the 100%. Clear? And there's a small thing to be mentioned in your schools and all. In different classes, in different schools, the definitions of these absolute errors, whether to get the least count or not, whether to get the half of it, the exact definition of a systematic error and a random error may change a bit, okay, based on schools and all, because these are not very established theorems. Different books give different definitions, okay. So there's a small fluctuation like that, okay. Clear? There's a small fluctuation like that. So the thing we have to do is, if your school teach something, write that in the term test paper, okay? Don't write what we are teaching, okay? If your school teaches something, use that for the term test. For A levels, ideally you can use this, but in doubtful areas like this, even sometimes you have something in the resource book, but sometimes in the marking scheme, the idea is a bit different, okay? So when it comes to like A levels, we usually every year we collect these doubtful areas and we'll mention what to do and what not to do when it close to exams. Okay, clear? When it close to exams, we'll let you know what is the exact definition that we consider for this. What is the exact definition that we consider for that? Okay, things we will mention. So you definitely have to use that for A levels. Okay, clear? So for term tests, for now use whatever the thing that they teach in your schools. Okay, for A levels, we'll tell what to do when it is close to exams. Okay, clear? And in my papers, you have to use this. Okay. So let's start writing a bit. Write the topic measurements and measuring instruments. So again, pay attention. So actually, writing a note is not actually necessary. Okay, we have everything required. Okay, you have everything required in the tute. Okay, so we are writing things just for the sake of remembering things. So we only write the most important areas. Okay, we only write the most important areas because we write things just for the sake of remembering them. And pay attention. We write things just for the sake of remembering things. So if you can anyways remember them, you actually don't have to write. So why do we include everything in the tute? Okay, it's 2 years of content. Okay, we usually, pay attention, we usually include everything in the tute. Even though we write a note, sometimes a short note, we include everything in the tute. Why? I mean, after 2 years, when it is close to exams, now you can remember, okay, I used like, this is my first book. Okay, this is the second one. It looks like there's a third one, but you can't find the third book. But you can find the fourth book. That's what usually happens when you write notes, right? Clear? You can't exactly remember what happened, okay? What happened with your notes. You can't remember the order. You can't find some books, okay? So when it happens, when it's close to exams, it's a problem. So that's why we give everything. So all you have to do is properly organize the tutes given by us. Then even if you lose 1 or 2 tutes close to exams, we can still give you the PDF or something, right? So still you have the required set of tutes to study, okay? Clear? That's why we include everything in the tute. It's up to you if you need a better short note. If you are a kind of person that remembers everything only if you write, there are people like that. If you are a kind of person who remembers everything only if they write, go home and write. Okay, you have the book. Okay, just look at the book and write everything. Okay, I'm not going to stop that. So you can just do whatever you need. Prepare a short note, highlight the book, underline the book. But if you can remember things only if you write things, just write the whole book. Okay, I don't care. Okay, you can do whatever you need to remember things. But just file these things properly, okay? File these things properly. Then you would at least have 1 note that you can study, okay? Close to exams. So we print everything, okay? So, we only write the most important stuff that you should remember. So only the categories would be enough, okay? So, check. Zoom and live. Okay, pay attention. Under that, write errors. So what matters is errors. Okay, errors. Measurements and measuring instruments topic. Under that, write the topic errors. Under errors, write these 2 errors. Systematic errors and random errors. Systematic errors and random errors. So under systematic errors, write errors that can be quantified. Errors that can be quantified. That is the shortest possible definition, okay? You have lengthy definitions and explanations in the book. Here we go with the shortest possible definition. When you see that, you know what is that, okay? That is the target, okay? Under systematic errors, right? Errors that can be quantified. Under random errors, right? Errors that cannot be quantified. This is the shortest possible explanation. Errors that can be quantified, errors that cannot be quantified. Quantified in the sense you can give a value. You can give a value. Quantify means having the ability to give a value. Okay. Systematic errors, errors that can be quantified. Random errors, errors that cannot be quantified. Okay. Then go to error analysis. Next topic, error analysis. So this is a very short note so that you can, go through that, and that's all you should remember. Okay. That's all you should remember. Whatever the things we write, that's all you should remember. Other stuff are just for the sake of completion. Error analysis, right? Topic error analysis. Write the topic error analysis. Under error analysis, write the absolute error. Under error analysis, write absolute error. Under error analysis, write absolute error. And with that, write this value equals reading plus or minus the error. Value equals reading plus or minus the error. And under that, write error equals least count over 2. Okay. Under that, write error equals least count over 2. Write this and this. Zoom here. Zoom here. Okay. Error value equals reading plus or minus the error. And under that, write error equals least count over 2. Yeah, definitely. There can be both the errors are present, okay, in any issue. So under error analysis, what I mentioned was under error analysis, you write the topic absolute error, number 1, absolute error. Under that, you write value equals plus or reading plus or minus the error. Under that, you write error equals least count over 2. That's all. Under error analysis. Next. Quickly finish writing. It's not always 0.5. It was just an example, okay? It is example for the meter ruler. Yes, you get questions from this. I'll mention. We'll do questions anyways. Okay. Is absolute error a type of systematic errors? No. Systematic error is a type of error. Absolute error is a way of quantifying the error. So, yes, you can only quantify systematic errors, but this is about error analysis, giving values for errors. That is about categories of errors, okay? 2 different topics. That is about categories of errors. This is about giving values for errors, okay? Clear? So the next one, 2, fractional error. 2, fractional error. 2, fractional error. Under that, write error divided by the reading, or error over measurement. Just write measurement. I prefer that. Error over measurement. Error divided by the measurement. Fractional error equals error divided by the measurement. Error divided by the measurement. Next, percentage error. Under percentage error, write error divided by the measurement into 100%. Error divided by the measurement into 100%. And write for 2 and 3. For 2 and 3, error equals least count. For 2 and 3, error equals least count. Error equals least count. For 2 and 3, error equals least count. Okay, next. Okay, pay attention. Now when it comes to these errors, okay, the percentage error, the fractional error, okay, we usually consider a measurement as accurate if the error is smaller than or equal to, so ideally if it is smaller than 1% percentage error, okay. Usually we consider a measurement as accurate, okay. Usually we consider a measurement as accurate if its percentage error is smaller than 1%, okay, or at least it is 1%. Clear? That means for an example, if you measure 5 millimeters using a meter ruler, what is the least count? What is the least count of a meter ruler? 1 millimeter, smallest measurement. Least count of a meter ruler is 1 millimeter. So the percentage error is going to be, here error is directly least count, 1 millimeter. When it comes to percentage errors, error is directly the least count, which is 1 millimeters divided by 5 millimeters, that is the measurement, into 100%, okay, into 100%. Clear? You are measuring 5 millimeters from a meter ruler with a least count of 1 millimeter. So you get what? 20% here, right? You get 20%. So this is way larger than 1%. So this measurement is not accurate. Clear? this measurement is not accurate. Clear? So ideally in science, okay, ideally in science, what we do is, if the percentage error exceeds the required value, we get a better measuring instrument, okay? Clear? Ideally in science, what we do is, we get a better measuring instrument. Better measuring instrument means a measuring instrument with a smaller least count. Clear? We get a measuring instrument with a smaller least count, so that we can get a better percentage error. Clear? But in our environment, in the lab and all, change in the instrument is not a possibility, okay? Change in the instrument is not always a possibility, okay? You can't just get a new instrument, clear, or a better instrument. So what we usually do is we change the measurement, okay? Clear? What is the meaning of change in the measurement? How can you change the measurement? I mean, you can do that. So, I mean, there are two ways of decreasing the percentage error, right? There are two ways of decreasing the percentage error. It is the error or the least count, error or the least count over measurement into 100%, okay? So you either get a measuring instrument with a smaller least count, or you consider a higher measurement. Clear? You get a very high measurement, okay? You get a very high measurement. Clear? So if in our labs, if reducing the least count is not a possibility, for that you need better instruments, okay? So if that's not provided, we increase the size of the measurement. How? I mean, assume that you have a pendulum. Assume that you have a pendulum, and this is a practical that you can see in the simple harmonic motion lesson or waves and oscillations lesson, okay? Assume a pendulum and you need to find the oscillation time of a pendulum. Oscillation time of a pendulum means it swings here, here, back here. That is one oscillation, okay? That is one oscillation. I said that there are like 40 something practicals in the syllabus. So this is one practical. You have to measure the oscillation time of a pendulum, and using that you have to find the gravitational acceleration, okay? Using that you have to find the gravitational acceleration. It's a different story. What we do is, here, okay, we have to measure it's a very small measurement, right? But you can't get a better stopwatch. So what you do is, instead of measuring one oscillation, you measure the total time for like 50 oscillations. Clear? One oscillation is a very small measurement. So instead of measuring one oscillation, you count like 50 oscillations and measure the total time. Then your measurement gets larger, right? Clear? If you measure for 50 oscillations, your measurement gets larger. Okay, your measurement gets larger. Then you get a better percentage error, right? Or sometimes you have to find maybe the gauge or the thickness of a A4 sheet. You have to measure the thickness of a A4 sheet. Clear? You have to measure the thickness of a A4 sheet. So this measurement is really small. So what can you do? You just fold it like maybe 5 times. You just fold it like 5 times or maybe 10 times. You repeat the same measurement and measure the full length, right? Clear? And later you can divide. Later you can divide and get the thickness, right? Clear? I mean, the thickness of a A4 sheet is really small. So you fold it several times, okay? So you fold it several times, clear? Then get the value. Clear? Can you remember there's a rule like you can't fold something more than how many? 7 times. I don't think that's true, right? It's not true, right? I don't think so. Why? I don't. Just try with a leaflet, you will be able to. I mean, there's a. Something you have heard that, right? You can't fold it something more than 7 times. I don't know. I haven't checked the correctness of it. But I mean, why not? Any scientific reason behind that for it to be correct? Yes, I have even heard that it is correct. Yes, haven't never checked that. Never searched about that. All right. I won't think that you would be anyways able to do that with leaflets, right? The leaflets are too small. You get a huge paper and try. Maybe. And A3 leaflets, did you get any A3 leaflet? Huge one. With a A4 leaflet, anyways, it won't be possible. Let's search. A standard piece of paper can typically be folded only 7 times. The world record for folding single piece of paper in one direction is 12 times. No, it can be, right? It can be. Some people are using what hydraulic press to do that and have successfully done that. See, people use hydraulic. People zoom this one. People use hydraulic. People use hydraulic systems and have done that. So physically, for a person, it may be possible or not, but mechanically, it's possible, I think. Anyways, uh, yeah, I saw that too. Mythbusters have done that until 11 times, right? They got I can remember Mythbusters did that with like a huge paper size of this hole or something like that and folded it more than 7 times. Okay. So let's try a few questions. Uh, a bunch of very simple questions. Exercise 1. 1, 2, 4, 8. Quickly go through these questions. And any online student who can't find the tute, put a message on the Zoom chat or in the YouTube live chat. Yes, definitely. Absolute error should be with it should have the same uh, unit. Yeah. Quickly go through these questions. Any physical student who don't have the tute? Any physical student who didn't get the tute? No, right? Continue. Quickly. Quickly try the questions. Go through the questions. Question 1, 2, 4 and 8. Won't take long for those questions, okay? Exercise 1, question 1. Pay attention. Exercise 1, question 1. When measuring lengths of rod A, B, C, D, E, F using lab meter ruler, we obtained 50 centimeters, 50 centimeters, 20 centimeters, 20 centimeters, and 5 centimeters. 5 centimeters. Okay. Now, what are the fractional error and the percentage error for each rod? So, the fractional error means error or the least count over measurement, okay? Error or the least count over measurement. So, this is what? This is a meter ruler. Least count is 1 millimeter. So, here the error is 1 millimeter. So, write both in the same unit, okay? Write both in the same unit. So, 50 centimeters means 500 millimeters, right? Pay attention. 50 centimeters means 500 millimeters, right? Why? 1 centimeter means 10 millimeters. 1 centimeter means 10 millimeters. So 50 centimeters means 500 millimeters. Here, again the least count is 1 millimeter, 200 millimeters. Here, least count is 1 millimeter. Measurement is 5 centimeters means 50 millimeters. 5 centimeters means 50 millimeters. Okay. Then the percentage error. Percentage error means error over measurement into 100%. So you get this, get the fractional error, multiply it by 100%. Get the fractional error and multiply it by 100%. Again get the fractional error and multiply it by 100%. Then we get what? 0.2%. Here 0.5%. Here 2%. 2%. Clear? 2%. Then for which of the above rods the meter ruler is not suitable to measure? Suitable to measure. Give reasons. So for this meter ruler is suitable. For this meter ruler is suitable. For this it's not. Why? percentage error exceeds 1%. So you can't use this. You can't use the meter ruler to measure this. Okay. In these two scenarios, percentage error is smaller than 1%, so you can use. Okay. In these two scenarios, percentage error is smaller than 1%. So you can use the meter ruler to measure these two. Okay, next. That's question 1, part 1 and part 2. Question 1, part 1 and part 2. Next one. Question 2. Question 2. The least count of a electronic balance. Least count of electronic balance is 0.01 grams. It is 0.01 grams. Then the fractional error. I'll just do that for one measurement, okay? Otherwise it costs a lot of time. 4 grams. So the fractional error is least count over measurement. Fractional error is least count over measurement. So the least count is 0.01 grams. Measurement is 4 grams. Least count is 0.01 grams. Measurement is 4 grams. Then the percentage error is 0.01 grams. That is the least count. Measurement is 4 grams into 100%. So here we get 1/4%, which means 0.25%. Here we get 0.0025. Fractional error and percentage error. Next. Question 4. Question 4. Fractional error in measuring one oscillation of a simple pendulum is, periodic time of one oscillation is 0.08 seconds. 0.08 seconds. Okay. To measure with a percentage error of 1%. To measure with a percentage error of 1%, number of oscillations that should be performed. So let's assume the total time that we are going to measure is n into capital T. Okay. Pay attention. Total time that we are going to measure is n into capital T. That means n number of oscillations. This is the number of oscillations. This is the number of oscillations. Clear? Okay. So n into one oscillation is 0.08. Okay. One oscillation is 0.08. This is the total time that we are going to measure. Okay. Again, now, so that is going to be the measurement. Okay. This total time is going to be the measurement, okay? Measurement is the total time. Then the percentage error means sorry, they are giving the fractional error in measuring one oscillation. Sorry, it's not the case. It's different. One oscillation is not 0.08. Fractional error in measuring one oscillation is 0.08. That means fractional error means error or the least count over one oscillation. That is the fractional error. Least count over the time of one oscillation. So they have given us the fractional error as what? Fractional error is given as 0.08. Fractional error is given as 0.08. And we have the least count that we don't know. I mean both least count and the periodic time. That means the time per one oscillation we don't know. Now we need a percentage error of 1%. That is the requirement for correctness. We need a percentage error of 1%. And what is the definition of percentage error? Pay attention. What is the definition of percentage error? Percentage error means least count over time into 100%. Least count over time or least count over measurement. Least count over measurement into 100%. Here the measurement is total time. So we can write least count over measurement is n into capital T. N number of oscillations here into 100%. Into 100%. Then we get here we have 1%, here we have this. I'll take n to this side. I have 1% equals least count over n t into 100%. I'll take n to this side. I'll take n to this side and 1% down here. So I have least count over t. I'll take n here and 1% down here. So you have 100% already here and 1% here. So percentage marks cancel out. You have least count over time over periodic time into 100. So least count over 100 is given as least count over periodic time. Least count over one periodic time is given as 0.08. So this is going to be 0.08 into 100, which means 8 oscillations. You have to get 8 oscillations. Clear? You have to measure 8 oscillations. Okay. T means the total time. Total time of n number of oscillations. Capital T is the time of one oscillation. Clear? Capital T is time of one oscillation. Okay. So they have given us the fractional error for one oscillation. One oscillation means least count over the periodic time of one oscillation. That is given as 0.08. I need a percentage error of 1%. For that, I'm going to measure n number of oscillations. So the total time is going to be n into capital T. That is the total time or the total measurement. So I'm going to write percentage error is least count over full measurement into 100%. That means least count over full measurement is the total time of n number of oscillations into 100%. This is total time of n number of oscillations into 100%. This is going to be my total measurement. So with this n number of oscillations, now I'm expecting to reach a 1% percentage error somehow. So 1% equals percentage error. That means least count over measurement. Measurement is the total time of n number of oscillations into 100%. Then I'm going to bring n here and bring 1% here. So I'll lift n here and bring 1% here, cross multiply. Then least count over time. So 100% over 1%, I get 100, right? Then least count over time, that means the fractional error for one oscillation. Least count over periodic time was given as 0.08. So I replace this by 0.08 into I have 100. So you solve this, you get 8. Clear? Did you get the answer? Did you understand the student who asked me to explain it? Just message everyone who asked me to explain it again. Next one, question 8. Oh, question 8 you can do, okay? It's okay. Let's go to the next part. N was taken here by cross multiplication. N was here, I got it here. 1% was here, I put it here. I cross multiplied that. Clear, everyone? Quickly put messages. Yes, total time is simple T. Total time, that means N into capital T. And physical class students, quickly ask questions from the invigilators. And if there's a lot of questions, they'll inform to me, okay? If there's a lot of questions from one area, they'll quickly inform to me. Okay? So ask from the invigilators. %, is for percentage error. N into T is the total time. N into T is the total time. N into capital T is the total time. That means the total time for n number of oscillations. N into T is the total time. That means the total time for n number of oscillations. Okay? Yes, total time is equal to the measurement is equal to capital N into T. Okay? Sorry, N into T equals the total time equals the measurement. Okay? It's the same thing. Anyone in the physical class? Just ask questions, okay? Just ask questions. Okay. Okay. Pay attention. Pay attention. Let's do it this way. Some students are asking me to explain that again. So, like, I'll do a small theory part and give a bunch of questions for you to try. Then explain this again, okay? I'll do a small theory part and give you a bunch of questions to try for everyone. Then explain again. And pay attention, everyone. Pay attention, everyone. Everyone. This is a very important thing. Like now, when you are doing science, ability to understand something fast, I mean, it's extremely important. Still, we are not in physics yet, okay? We haven't started physics yet. So mechanics, when we reach mechanics, it will be extremely difficult, okay? At the end of the day, it's going to be difficult. Why? You have to have a good, pay attention everyone, stop talking. You have to have a very good ability in understanding things fast, okay? Few things happening from our side too. Math sessions happening on Thursday mornings, it's just for you to clarify basic stuff. If you were finding them difficult, it's a different story. And we were planning, pay attention. So we were planning to start another time slot to do difficult questions and go with extremely difficult questions and move faster, an entirely different time slot. But still, it's very difficult to find a time slot like that. Clear? Even this class time, we informed many teachers not to use this class time and arrange this. Okay? We just send messages to everyone. Okay? Just don't, this is our class time, don't use this, we need this time. Okay, we were not able to do that for 2 time slots. We should have done that, but we were not able to do that for 2 time slots. So it's very difficult to find another time slot that people don't have classes. For 29 batch, I'm going to reserve 2 days, okay? Usually in English medium, when we ask, they do that, okay? Because anyways, we are not going to change our time, that's why. But anyways, but since it's difficult to find a time slot like that, that's why I added 1 hour to the end of the class. At least we can start there. Okay? That's why I added 1 hour to the last part of the class, to the end of the class, from 6:30 to 7:30, so that we can start at least from there. That means in the 6:30, 7:30 time slot, I'm not going to explain things again. I'm not going to move slowly. Okay, I'm not going to explain anything again, okay? You just try to listen, try to understand things as fast as possible, okay? There should be an additional time slot like that, because I can't do that in the main class at the moment. Why? Then many students would struggle. But the story is, we have to move faster, okay? We have to move faster. You have to be able to understand things faster. Some students may have the ability at the moment, some may not. For the students who don't have that ability to understand things faster, work on it, okay? Work on it. Definitely try to stay in the 6:30, 7:30 time slot. Try to understand things, try to do questions faster, okay? Go through your maths books again, okay? So try to improve yourself, okay? Try to improve yourself. Why? Again, I'm going to repeat, A levels is like, not actually 100, like 1500 times difficult than O levels, okay? O levels is not an exam, okay? For sure. I mean, O level maths, it's like 0.00001% of our physics syllabus, okay? Clear? The whole O level syllabus, it's not a big deal. So you have to like work on you, okay? You have to try to improve. So stay in the 6:30, 7:30 session. It's not mandatory. It's not for a A, okay? It's not for a A. That means it's not like if you are not staying for 6:30, 7:30 session, if you are not understanding the 6:30, 7:30 session, it's not like you are not going to get an A. You understand everything in the main class, you can go for a A. But at the end of the day, how easy are you going there would entirely depend on your thinking capacity, okay? and your ability to learn fast. Okay. How easy are you going to go for an A? Okay. So you have to work on your intelligence and thinking capacity and how fast you can learn. Okay. So that it would be easy to reach an A. Otherwise, you always have to struggle. So in the initial 6 months, you have to work hard, do a lot of questions, try to do difficult questions. That means, can you remember that single page I gave you on the first day? There are some students who finished that. There are some students who tried that, and some students are still trying that. So students who finish that, yes, you are at a good position. You keep doing that, you can go for A. Students who keep still try that. Students who were not able to do that, but there are students who still try that. Congratulations, still, you are going to go for A. Why? You keep trying means your intelligence will keep improving. But definitely there's a set of students, you check that for the first day, you check that for the second day, were not able to understand that, so you didn't bother to look at that again. Okay? You didn't bother to look at that again. So whenever we give some difficult questions, some students do that. Some students, at the moment they finish, you are at a good position. If you keep doing that, you are going to end up with an A. Some students keep trying. So still, definitely they are going to get A. The students who keep trying that, there are some students I know, they still try the tute. They have a higher possibility of reaching an A than the students even finished on the first day. Okay, why? Because they have the ability to keep trying even when you are not understanding anything. Some students are like that. You don't understand, you can't figure that out, but you keep trying forever sometimes. Okay, clear? They definitely get an A. Okay, why? That is the attitude what matters. Okay, they anyways get an A. Okay, if there's a student who still try that tute after this 6-7 weeks, okay, if there are students who still try that, that means you're definitely gonna get A. Okay, that attitude matters. Okay, but the students who the students who gave that up, it was not there to complete. Okay, that tutes, the difficult question tutes that we give, they are not there to complete or to finish. They are just there for you to struggle with that question. Because that struggling is what improves your brain. That's what makes your brain think faster. Okay, that's what makes your brain ready for real A levels. Okay, the purpose of difficult questions is that it's not for you to complete. So that extra question book you will never be able to complete. Okay, so those questions are not there for you to complete. Those questions are not there for you to try and get answers. Some students would be able to get the answers, but the purpose of it is not getting answers. If you just keep trying, even though you can't, okay, so that process, that struggle, okay, that struggle will help you to develop your brain and make your brain ready to A levels. Okay, so that is the target. So you have to work with us for that. Okay, clear? You have to be ready to struggle. Okay, you have to be ready to struggle if you are doing science for A levels. Okay, that's where we are heading. Okay, so today, now it's only 1 hour for difficult questions. It's only 1 hour, 6:30, 7:30. Why? Because we don't have a lot of physics to do. So we have to do some maths, some physics, like that. Still, we don't have a lot of difficult physics to do. But in the future, if possible, we try to use a separate time slot, maybe 3 hours, entirely to do difficult questions and to do things faster, to do extremely hard questions, to make it really difficult for you guys, so that you would improve. Okay, clear? So keep it in mind. The parts you are not understanding, parts you are struggling, those are the parts that would help you to improve. Okay, if you understand everything clearly, if you understand everything 100%, then there's a problem. Again, I return, this is very important for your combined maths classes. Okay, you can't understand everything happening in your combined class. If you understand everything happening in your combined class, that means your combined maths class is not improving your brain, and you still have a O-level brain, not an A-level brain. So your brain is not going anywhere with that combined maths class, okay? Because every week, even last week, some students talked with me about the combined maths class. It's a very frequent question. The basic criteria is, I'm not going to give recommendations, but the basic criteria is you should not understand everything explained in the combined maths class. Don't change your combined maths class just because you don't understand some points, okay? Clear? You just stay in that class, because if you're not understanding things, it's good. Okay, you should not understand a certain part happening in your physics class. You should not understand a certain part happening in your combined maths class. I don't know about bio. Chemistry, yes, kind of, you should not understand a certain part. Okay? For bio, I don't know. I think you are supposed to understand everything, right? In bio. Okay. Pay attention. So I'll explain that again. But before that, I'll finish a small part of theory, okay? I'll first finish a small part of theory, then others can try the questions. Pay attention. This part I'm going to explain, it's not in the syllabus, okay? This part I'm going to explain, it's not in the syllabus. Then why do we learn that? Still, they consider that we have that common sense, okay? That is the problem. Pay attention. Fractional errors and percentage errors of combined measurements. Pay attention, stop talking everyone. Fractional errors and percentage errors of combined measurements. It's included in your tute, and even in the tute we have mentioned that it's for, it's in the page 3. Even there we have mentioned that this is for additional knowledge only, but that you have to know, okay, because it's not in the A-level syllabus directly, but the knowledge is used in A-level syllabus. We'll see why. So pay attention. This is L. This is D. So usually we write the fractional error as fractional error of L. Fractional error of L is, we write it as delta L over L. Fractional error of L is delta L over L. Fractional error of D is delta D over D. Pay attention. Fractional error of L is delta L over L. Fractional error of D is delta D over D. This is a standard notation. L is the measurement, delta L is the error of that measurement. D is the measurement, delta D is the error of that measurement. Okay? This is a standard notation that we use. So you know the fractional error of length, you know the fractional error of D, but the area is L into D, right? Area is L into D. Clear? Area is L into D. So what is the fractional error of area? What is the fractional error of area? How can we get the fractional error of area? So that there's a rule like this. Fractional error of any multiplication is equal to the sum of the fractional errors of each quantity. Clear? Is equal to the sum of the fractional errors of each quantity. Clear? If area is length multiplied by D, L into D, fractional error of A is fractional error of L plus fractional error of D. Clear? Then like Think about a scenario like this. There's a quantity P which is equal to, and it's for multiplication and division both, okay? That means if it is LR over D, still the fractional error of P is going to be delta L over L plus delta R over R plus delta D over D. Clear? Still the fractional error is going to be delta L over L plus delta R over R plus delta D over D. Clear? So for subtraction it's not minus, okay? Even for multiplication and subtraction, still it affects the result. So the fractional error of the combined measurement is just the sum of the individual fractional errors. Clear? Then what about measurement like this? We usually know that volume is L cube. Volume is L cube of a cube. Okay? That means it is L into L into L. So delta V over V. Delta V over V. Fractional error of V. Delta V over V. Fractional error of V is equal to what? It is equal to delta L over L plus delta L over L plus delta L over L. Clear? Because it's L 3 times, okay? Which means 3 into delta L over L, right? So if you have a power like this, fractional error of this quantity is going to be equal to the power into the fractional error of individual quantity. Clear? That's how we calculate the fractional error of multiplications and divisions. Okay? That's how we calculate the fractional errors of multiplications and divisions. Okay? Then again, like if A equals, then R S squared over L half. So what is the fractional error of A? It is going to be delta A over A. Fractional error of A is going to be fractional error of R, delta R over R. Fractional error of R plus 2 times, right? It is S squared. See, L cube was 3 times delta L over L. Like that, here it is 2 times delta S over S. It's going to be 2 times delta S over S. Clear? Then this is to the power half, right? So it is half delta L over L. Clear? It's half delta L over L. Clear? Got the idea? Okay. Always the power affects this. Okay. So this is not in the syllabus. Okay. This is not in the syllabus, but in the term test you are going to get a bunch of questions from this anyways. Okay. And in A levels, still they think that you know this. Okay. That is the problem. It's not in the syllabus, but they assume that you know this. How? A common question. This question was there in A levels. In the last lesson, there's something called, not the last lesson, the lesson before the last lesson, there's something called the Poiseuille's equation. Poiseuille's equation is volume over time equals pi over 8 r to the power 4 over neta. Neta is the viscous coefficient. Pressure over length. There's an equation like this, okay? There's an equation like this, okay? Poiseuille's equation. This is the lesson before the last lesson, okay? So here we have a practical from this equation, okay? There's a practical from this equation. In that practical we measure everything. We measure the volume. We measure the time taken to fill that volume. This is the radius of that tube. So we measure the radius. This is the pressure felt by that tube. This is the length of that tube. Like that we measure everything, okay? There's a practical. In that practical, in one year they asked, in A levels, they asked when measuring, which measurement should you be most careful about? Like what is the most critical measurement? What is the most critical measurement and why? Should you be careful? I mean, when getting the volume or time or length or pressure or radius, when measuring what quantity or what is the most critical quantity that affects this practical? What is the answer? It is the radius, R. Why? The answer they expected was error of, the accuracy of a measurement usually boils down to its percentage error. And accuracy of a combined measurement can be evaluated by its total fractional error. Okay, accuracy of a combined measurement can be evaluated by its combined fractional error. So the answer they were expecting was the fractional error of R gets multiplied and affects the total fractional error of the result. That means when you are writing the total fractional error, since it is R to the power 4, it becomes 4 times delta R over R, right? This is not in the syllabus, okay? But the answer they were expecting was the fractional error of the combined measurement, the fractional error of R gets multiplied and affects the total fractional error. Because of this reason, okay? So it's not in the syllabus. You may never get mathematical questions from that. Okay? You will never get mathematical questions from that. To solve things, no. But theoretically, they always check this knowledge, okay? Whether you understand the concept, okay? They can't give you mathematical questions from this, but they can check whether you understand the concept. If it is to the power 4, they check whether you know that it affects 4 times to the total fractional error. Clear? They check that knowledge, okay? So sometimes things are not in the syllabus, but that doesn't mean that they are not going to ask that, okay? Clear? Okay, so this you don't have to write anything because it's not in the syllabus, but we'll do a bunch of questions to understand that. So try the next set of questions. Now you can try 8, I think. You can try question 3. If you are done with that, try that extra tute, okay? Extra tute today given for 6:30, 7:30 session. Try that if you are done with these questions. Try that extra tute, okay? Yes, even for division you have to add, yes. Question 3. Question 5. Question 6. Question 7. Question 10. Try these questions. So I'll explain this one time and give you the interval. Others can try those questions. Okay. Pay attention, pay attention. And again, like in many scenarios, you misunderstand understanding with not focusing. Okay, that means including, I mean, this generation, including, I mean, you, but I mean, even I was there. I mean, we use mobile phones a lot. We don't have a huge attention span. Okay, we don't have a huge attention span, so there's a high tendency of we losing focus again and again. Okay, so in many cases you misinterpret that as not understanding something. That means you were not listening. Okay, time to time. Sometimes even you are, even sometimes this is very critical for you guys. Sometimes even you don't know that you are not listening. Okay, that means your brain is so used to not focusing, so you can't figure out when you are not focusing. Okay, that means you think you are listening, your brain goes here and there time to time. Okay, as a result you can't, like, at the middle you lose a small part. After that you can't connect things. You think you are not connecting things because you are not understanding things, but the thing is it was just an issue of focus. Okay, that is the main issue you have, not the intelligence, it's the focus. Okay, clear? You don't need intelligence for A levels. Okay, you need intelligence for Olympiad exams and stuff. The main thing you need is focus. So work on that. Work on that means if you are using mobile phones and all, I mean, I'm not going to ask you to throw them away, but I mean, learn to live with that if you have a mobile phone. That means I have mentioned these things before. I mean, when we are working, we time to time get the mobile phone to check, right? Okay, I mean, don't keep your mobile phone close to you even when you are watching a movie. Okay, clear? Assume you are watching a movie on the TV or maybe the tab or something. Don't even keep your mobile phone there. Why? Still you get the mobile phone, right? You're not watching the movie. You get the mobile phone and do something, right? So that's you're training yourself not to focus. Clear? That you're training yourself not to focus. So even when you're watching a movie, keep your mobile phone out of your room. Now watch the movie. Okay? Clear? If you're studying, still, I mean, keep a dedicated place for your mobile phone outside of your room. Why? When you're working, after a while you don't know when you got the phone, right? Because you are so connected with that. Now when you're working at home, if your phone is just outside your room, you are going to do that. Okay, that means you are going to get the mobile phone, but when you're searching for the mobile phone, it's not there. So you stand up and go for the mobile phone, but on the way you figure out you actually don't need that. Okay, I mean, your brain is so connected with the mobile phone and all, but if you give a small space, pay attention, if you give a small space, that means like 2 seconds for your brain to figure out, it figures things out. That means if there's a 2-3 second gap in between you needing the mobile phone and you getting the mobile phone, if there's at least a 3-4 second gap, you're going to figure out that you don't need the phone at the moment by yourself. Okay, but the problem is you don't have that time. When it's next to you, you get the tendency to get the phone, you get that. But when it's just like few meters away, I'm not asking you to throw that away. When it is few meters away, you get that, now you have the tendency to get the mobile phone. You stand up, go for the mobile phone, but within 2 seconds you understand, okay, you don't actually need the mobile phone at the moment. You return. That happens. Okay, and again, don't go there and bring the mobile phone. Go there. I mean, let's assume you need to text with someone. Okay, you go there, you text. When you are texting, focus on that. Don't focus on your book. Okay, focus on that. You text, you keep the mobile phone there and return to the book. Now there's a gap between things, so your brain doesn't confuse things. Okay, clear? You just need that gap. If you need to go 10 times and text, go 10 times there, text and return. Then after like 10-15 times, even you would get, I mean, you won't need the mobile phone. Now you are tired. Okay, as a result of going there for 10-15 times, now you are tired. So you don't go there often, you go there like every 30 minutes. It's okay. Clear? You need that gap. Otherwise, our brains, I think even you guys, from your birth, they have a digital stuff, right? So you are so connected. So when you get that tendency to get the mobile phone to your hand, you can't stop that. You can't stop that. You need like 2-3 seconds to figure out that you don't need that. So you always, I'm not asking you to throw the mobile phone away. I'm asking you to give that 3-second gap. Within that 3 seconds, you will figure out whether you actually need that or not. If you think you actually need that, okay, even for something useless, okay, still you need the phone. Okay, you go there, okay, stay there and like text or do whatever you do and return. Clear? And return. Not with the phone. Keep that gap, okay? Then you will then you will learn how to focus, okay? Without this ability to focus, you won't get anywhere, okay? It's not an intelligence problem in many scenarios, okay? It's not an intelligence problem. With new generations, new batches, every batch, sorry for telling this, every batch loses the ability to understand science, okay? Every batch it happens, okay? And when we analyze things, it's not an intelligence related issue. Okay? It's not an intelligence related issue. It's always a focus related issue. Okay? Every batch lose ability to focus. Okay? Every batch lose ability to focus. Okay? 27 batch focused more than you guys. 29 batch won't focus like you guys. Like that, every batch lose ability to focus. Okay? You have to pre-gain that. Okay? That is the must. Okay? That is the most important thing. So work on that. Have a dedicated place for your mobile phone and digital stuff. When you need that, you go there. When you're using the mobile phone, focus on that. When you're eating, eat. Okay? Just keep your mobile phone at the dedicated place. Eat. While eating, now you always need the phone, right? So go there while eating. Then even you will feel tired of that. Then later stop that. Okay? Go there while eating, go there. Text, then return and start eating. Then when you do that 2 times, you get tired of that. You just finish eating, right? Then go to the mobile phone. Then after a while you learn, okay, now I'm eating, I'll eat within 15 minutes and go to the mobile phone and use that for 10 minutes. Like that, then you get adjusted, get used to that, right? Clear? Don't use the mobile phone while eating. Then you eat for half an hour while using the mobile phone. Instead, eat for 15 minutes, use the mobile phone for 15 minutes. Same 30 minutes, right? But you learn to focus. You focus on the food for 15 minutes, you focus on the phone for 15 minutes, which is good. Then you are training yourself to focus. Clear? Don't eat while texting for 30 minutes. I'm asking you to eat for 15 minutes and text for 15 minutes. Then you do these things separately, you learn to focus. Clear? Within like 6 months, you will see a change, okay? You will see a change. You will, all of a sudden, you understand things. It's not because you improved your intelligence, it's because you improved your focus, okay? That is the fundamental thing. If you are not doing this, I can't help you, okay? We can't do magic, okay? If you are not doing this small thing, we can't help you, okay? You are not going to get anywhere in science, okay? Okay? Just leave the stream, okay? Just leave the stream. If you can't do this small thing, if you can't improve focus, you are not going to get anywhere in science stream, okay? Never, okay? At the end of the day, you have to be an engineer or a doctor, okay? You can't text while doing a surgery, okay? So at the end of the day, you don't have a career. You don't have a career in science if you can't correct that part, okay? If you can't correct your focus, you don't have a career in science, never. Don't even think about going to a private university and becoming a doctor. Still, you're going to be a bad doctor. So no one going to believe you, okay? So don't think about a career in science if you can't work on your focus, okay? Now start working on the focus, okay? In many scenarios, it's not the intelligence, it's the focus, okay? Okay? So try these questions after the interval. Just after the interval, I'll explain this again, okay? So it's 26. Let's take a small interval. So yeah, be here by exactly by 5. Yeah, it's 5:45. Be here by 5:45. Uh, and if you need me to explain this again, if you need to hear the explanation again, be here exactly at 5:45 because I'm going to explain this exactly at 5:45, okay? Others can have like 3 additional minutes. Check. Okay. Pay attention. Anyone who need me to explain this question again? Others try these questions. Okay. Others try these questions again. Okay. Others try these questions again. For others, like anyone who need me to explain this again, focus. And there were some important questions related to this too, okay? That means although some few students ask about this, there were some important questions connected with this too. That is, pay attention, that is like fractional error and percentage error is not about what we need to find. Fractional error and percentage error is not about what we need to find. That means here, at the end, I need to find the periodic time or capital T of the pendulum. That means time of one oscillation. But when it comes to fractional error and percentage error, pay attention, stop talking, pay attention. But when it comes to fractional error and percentage error, it's never about what we need to find. It's about what we measure. Clear? That means if it's true that you need the total time for, it's true that you need to find the time of one oscillation. But when you measure 50 oscillations, fractional error is connected with the total time of that 50 oscillations. Clear? Fractional error is connected with the total time of that 50 oscillations. Clear? Got the idea? Later you divide it by 50 and get the time for one oscillation. It's a different story. So for fractional error, it's not about what we need to find. It's about what we measure. Clear? Okay. So you can still get what you need to find. How? You measure for 50 oscillations, divide by 50. So you still get what you need to find. Clear? But you do that by measuring a larger time, which makes your percentage error lower. Clear? So here, now what they have mentioned is, if you measure one oscillation, this is your fractional error. Okay? If you measure one oscillation, this is your fractional error. That means time of one oscillation, least count divided by time of one oscillation. That is given as 0.08. Clear? That is the fractional error for one oscillation. Now they are asking you to make the percentage error 1%. So you need a 1% percentage error. You can never reach that by measuring one oscillation. So what is the solution? You measure a larger time. That means you make the measurement larger by measuring n number of oscillations, which will make the total time n into t. You measure something larger. Clear? You measure something larger. Okay? NT. So now, percentage, when it comes to percentage, it's not about what we need to find, it's about what we measure. So now the measurement is NT. Now the measurement is NT because the total time I'm measuring is now large. Clear? So the total time is NT. So here you have least count and total time is NT. Clear? Least count divided by total time NT into 100%. Clear? This is the total time that you are going to measure. This is the least count into 100%. That is the definition of percentage error. Here it's not about what we need to find, it's about what we measure. And here we measure the total time of n number of oscillations. Clear? Which means NT. So least count divided by NT into 100%. Clear? But now I have to somehow find that. So 1% equals this. I have to make this 1% somehow. So for that, now I have this equals this, okay? Now, I have to find for n. So I'm going to bring this n here and 1% here. Cross multiply. Bring this n here and 1% here. Percentage marks cancel out. I have least count over time into 100. And they gave me the value of least count over time. They didn't directly tell me that that is least count over time. They said that it is the fractional error of one oscillation. That means when you are measuring one oscillation, that means 1 t, least count divided by 1 t equals 0.08. Clear? So that they gave. So I can directly put it here. Into 100, I get 8. Clear? Got the idea? Online students who asked me to explain things again? Is it clear? Yeah. The number of it should be larger than or equal to n. Yes. And like online students, anyone, I mean, there are different students joining from different platforms. Some students are from the website, some students are from the Zoom, and some students are from the YouTube live. But I mean, for everyone, okay, you don't have to contact institutes to get the tubes delivered, okay? We are handling it. So send a message to this number, 070 786 6277, because some students haven't received the tubes and they have asked that from the institute. No, you don't have to ask that from the institute, and institute will not send you tubes. We are sending the tubes, okay? 070 786 6277. So I think even for measuring instruments, we have sent close to 700, we have delivered close to 700 tubes, okay? So like almost lot of students should have received, okay? Only English medium tubes, we delivered close to 700, okay? We delivered close to 700 English medium tubes. So most of the students must have received that. Okay. Okay. Exercise 1. Question 8. Exercise 1, question 8. Pay attention. This is a very important question. This is a very important question. Stopwatch has a least count of 0.2 seconds. Everyone listen. Stopwatch has a least count of 0.2 seconds. If the time measured for 40 oscillations is 50 seconds, time measured for 40 oscillations is 50 seconds. Find the percentage error in the time period. So time period means time period means one oscillation. And this is for 40 of them. This is for 40 of them. Clear? Okay. This is for 40 of them. Now, now the thing is this, okay? So what is the percentage error here? I think sometimes the answer may be wrong in the answer script given here for this. Percentage error, they are asking what? Yeah, percentage error for total measurement. Pay attention. Pay attention, stop talking everyone. What is the percentage error for total measurement? So, percentage error means least count over measurement into 100%, okay? Least count over measurement into 100%. Okay? So now, least count of the instrument is 0.2, okay? Least count of the instrument is 0.2. And the measurement is 50 seconds. Total measurement, pay attention. Pay attention, stop talking. Total measurement is 50 seconds into 100%. So here you get the answer what? You get the answer 0.4%, okay? You get the answer 0.4%. Okay, pay attention. So now, this is for the total measurement, but they are asking the percentage error for one oscillation, okay? Is it the answer given? I don't think that they not have given the correct answer most probably. Oh no, they have given the correct answer. It's good. Yeah, we have the correct answer. Pay attention. Answer is not going to change, okay? They have given the same answer, right? Answer is not going to change. Okay, why? As I mentioned, percentage error is not about what you need or at the end what you find. Percentage error is about what you measure. Clear? So even for one oscillation, you are not measuring one oscillation. This is a very different story, okay? Even though you need one oscillation, the periodic time of one oscillation, you are not measuring one oscillation. You are measuring 40 oscillations instead, and the total time is 50 seconds. So, I mean, The meaning of that is you are using a stopwatch. You are using a stopwatch. It can make an error of 0.2 seconds. It can make an error of 0.2 seconds. And using that, you are measuring 50 seconds total. We don't care what you need to find at the end of the day. The percentage error of this measurement is 0.2 over 50 into 100%. Okay? Now, since this is the percentage error of that measurement, later if you divide the reading and get something else, still the percentage error connected with that measurement is this. Got the idea? Clear? Still the percentage error connected with this measurement is this. That means percentage error is about the measurement. It's not about what you need. So you need to find the periodic time of one oscillation. Pay attention. So you measure 40 oscillations and get a total time of 50 seconds. Get a total time of 50 seconds. Okay? Then the percentage error connected with that measurement is this. Clear? So whatever you derive later using this by dividing 50 or anything, still you are gonna get the same percentage error, right? Nothing's gonna change. Clear? Nothing's gonna change. That is the percentage error connected with the measurement. Clear? Nobody cares later what you need to find. Okay? You may need the periodic time of one oscillation, but if you measure the total time of 40 oscillations and get a total time of 50 seconds, your stopwatch is measuring that 50 seconds, not the time of one oscillation. Clear? So in that case, your percentage error is still this. Clear? Got the idea? I can explain it in a different way. Now try this. I'll try to explain that in a different way. Okay? Try this. So now this is the total time, right? This is the, so pay attention. Total time is 50 seconds, okay? Pay attention. Total time is 50 seconds. And the fractional error of total time would be 0.2 over 50, right? Total time is 50 and there's an error of 0.2 seconds. The least count is the error. Clear? This is the fractional error of the total time. Clear? Now I need to find the time of what? Now I need to find the time of one oscillation. Okay? Now what can I do? I get T, that is the total time, and divide it by 40. I get T and divide it by 40. Why? This was the total time for 40 oscillations. And I need to find the periodic time of one oscillation, so I divided this by 40. So now, can you remember the equation for combined measurements? Delta T over T. That means the fractional error of time. Delta T over T. That means the fractional error of time. One oscillation, one periodic time. Fractional error of one periodic time. Clear? Equals what? Now see, this is a division, right? So fractional error of this is fractional error of this plus fractional error of this, right? That means delta T over T plus the fractional error of this. I don't know how to write that. Maybe delta 40 over 40 or something like that. This is not a measurement. There's no error. It's a number. So there's no fractional error in a number, right? 40 is just a number. There's no fractional error in a number, right? If this was a measurement and this was a measurement, you have to add the two fractional errors. Clear? You have to add the two fractional errors. Okay. So this is the division. So you write delta t over t, fractional error of the total time, plus the fractional error of 40. That means delta 40 over 40. Okay. But there is nothing like delta 40 over 40. 40 is a value, number. It's not a measurement. There is no error there, right? There is no error in 40, right? It's just a number. Clear? So delta 40 is 0. There is no error for 40. So you get delta t over t equals delta t over t. See? So the fractional error of total time is going to be equal to the fractional error of one oscillation. Clear? That's why I said that at the end what matters is the fractional error of the total measurement. Clear? At the end what matters is the fractional error of the total measurement. Clear? Nothing else. Clear? At the end of the day, if you derive something using that by dividing 50 or something, still you are going to have the same fractional error and percentage error. Clear? Got the idea? So, hope you understood. Put a message on the chat. And physical class students, ask if you have any questions. So later you multiply by 100%, then you get the percentage error. How to get the recording of the class? You can go to entirely online students. You can get that from the Sysygy online platform. You can get that from the Sysygy platform. You go there, you have an account. You can create an account. When you pay here, your account anyways get activated. You go to the website and get the recording. Okay? Clear? If you are not in the group, today join the group. We'll provide all the information again in the group. Okay? We'll provide all the information again in the group, how to get recordings and all. Okay? So join the group. If you are not in the group, join the group. Physical class students, I think we send a paper, right? To get information of new students. So if you fill that paper, new students will be added to the group, okay? And new students, you can stay after the class and talk with me and get the recording. So clarify whatever the issues you have, okay? Is it okay to buy resource books for physics? I mean, yes, you can buy, but I think it's not actually necessary. I mean, we actually steal all the content from the resource book. I mean, you go and check last year's units and dimensions book. It's not equal to this year's one. So every year we prepare new tudes. So we get content from resource books everywhere, things we missed from last year, everything, connect everything. And for every batch we prepare a new tude. So everything is usually included in your tude, okay? So if you like, yes, buy resource books, but it's not necessary. Okay, we try to include everything. Okay. So next week we are going to move into measuring instruments. Okay, like we have a bunch of measuring instruments here. So we'll check the measuring instruments and start working on with them by next week. Okay, and in the same measuring instrument box, I mean, like we send something to measure with the measuring instrument sometimes. We ask students to share that and ask them to measure something. So last week we found a fork. Okay, so we just sent the fork and this is how we received it. You can zoom it. So it's there. I mean, people are pretty creative, right? I mean, they have perfectly done that. So this year you are not going to get anything to measure. You just measure something that you need. We are not going to send anything. I mean, you should see that from side. It's actually pretty accurate. I don't know whether you can see that or not. It's like perfectly crafted. See? Let's move forward. Question 3. Area equals L squared. Area equals L squared. Again, pay attention everyone. Pay attention. Like, I mean, this is how in A levels, if they need you to use that equation, this is how they would give that, okay? They would give the equation and ask you to use that, okay? Clear? See, in the third question, we have given the equation to be used, right? So in A levels, they can do that with anything, okay? With any equation, they can do that, okay? Clear? In A levels, they can do that with any equation. That means any complex equation, they can introduce the terms and ask you to use that, okay? So here they have given us delta A over A. That means the fractional error of A. Delta A over A, fractional error of A, equals 2 into delta L over L. Delta A over A equals 2 into delta L over L. So now, find the fractional error of A and, okay, first the fractional error of A. So delta A over A is the fractional error of A equals 2 into delta L over L. That means the fractional error of L. So it's measured using a ruler. It's measured using the ruler. So one side length L is 20 centimeters. 20 centimeters means 200 millimeters, okay? Pay attention. 20 centimeters means 100. 20 centimeters means 200 millimeters. Clear? Okay. 20 centimeters means 200 millimeters. Now, 2 into delta L over L. Delta L, usually if they mention ruler, that means it is a meter ruler. So for a meter ruler, delta L is 1 millimeter, okay? For a meter ruler, delta L is 1 millimeter. Clear? Okay. For a meter ruler, delta L is 1 millimeter. So we can write 1 millimeter over 200 millimeters, okay? 1 millimeter, delta L 1 millimeter, that is the least count of a meter ruler. Least count of a meter ruler divided by the measurement, which is 200 millimeters. Then you get what? 1 over 100 as the fractional error. You get 1 over 100 as the fractional error. And they are asking the maximum error delta A2. How can you get delta A now? Pay attention. How can you get delta A now? You can get delta A by, you can calculate A. Why? A is L squared. L squared means 20 centimeters into 20 centimeters, which means 400 centimeters squared. Pay attention. Area is 400 centimeters squared. Now you have delta A over A. Now you have delta A over A equals 1 over 100. So you get delta A over A. Here A is 400 centimeters squared. Delta A over A. A is 400 centimeters squared equals here 1 over 100. Equals 1 over 100. Delta over A over A. A is 400 centimeters squared equals 1 over 100. Then you get what? Delta A equals 400 centimeters squared over 100. Then you are going to get 4 centimeter squared. You are going to get 4 centimeters squared. Okay. Yes, you can use centimeters instead of millimeters. Then both should be in centimeters. Okay. Both should be in centimeters. Question? Sorry? Delta L equals 1 millimeter because they are mentioning about the they are mentioning the measuring instrument as a meter ruler. So in a meter ruler, least count is 1 millimeter. So can you remember when it comes to fractional error and percentage error, when it comes to fractional error and percentage error, delta L is the error, delta L is the error, and for pay attention, for fractional error and percentage error, delta L or the error is considered as the least count of the instrument. Can you remember? Delta L over L means the fractional error of L. Delta L over L means the fractional error of L. And delta L means the error of L. And for the percentage error and the fractional error, error is the least count of the instrument. Clear? Can you remember that? You write the least count of the instrument here, and here they are talking about a meter ruler. So in a meter ruler, least count is 1 millimeter. Clear? That's why the error is 1 here, 1 millimeter over L is 20 centimeters, which means 200 millimeters. Clear? Got the idea? Okay, clear? So later, pay attention, later I get delta A over A as 1 over 100, okay? Pay attention everyone. Later I get delta A over A as 1 over 100. So fractional error doesn't have a unit, okay? Why? Fractional error can't have a unit. It's a area divided by area. Clear? Fractional error can't have a unit. It's an area divided by area. Again, here length divided by length. Length divided by length. So fractional error will never have a unit, right? It's length divided by length into 2. You get area divided by area. So it's unitless anyways. So now you get the fractional error, and this is unitless, okay? This is unitless. Clear? Fractional error is a unitless thing, right? Okay, so it's a area, delta area. That means a change, error in area divided by area. So now you have this. So now if you write area in centimeter squared, you get delta area in centimeter squared. If you write area in millimeter squared, you get delta area in millimeter squared. If you write area in kilometer squared, you get delta area in kilometer squared. That's why for here, I use delta A over 400 centimeters squared. Then delta A is in centimeters for sure, right? Then I cross multiply, get the answer and write it as centimeters squared. Clear? I make them the same unit, millimeter, millimeter, so that the units cancel out. Then I find the fractional error. Since the units cancel out, fractional error won't have a unit. Fractional error won't have a unit. Clear? Now, so since fractional error don't have a unit, if area is measured in centimeters squared, delta area is also in centimeters squared, right? So I write 400 centimeters squared. Then when I solve this, I get delta area again in 4 centimeters squared. Clear? Got the idea? Let's try question 6. Question 6. So it's a cube. It's a cube. So side lengths are L. Pay attention, everyone. Now stop talking. Pay attention. Pay attention. Last rows, pay attention. So now they have given me what? Percentage error for the surface area of one side. So surface area of one side means L squared. Then they are asking the percentage error for volume. Volume means L cube. Volume means L cube. Clear? Area is L squared. Volume is L cube. Then delta A over A. Fractional error of area is going to be 2 into delta L over L. Can you remember? Pay attention. Fractional error of area is going to be 2 into delta L over L. Clear? And the fractional error of volume is going to be 3 into delta L over L. Fractional error of volume would be 3 into delta L over L. Clear? So now you multiply this by 100%. You multiply this by 100%. Delta A over A into 100%. You get the percentage error, right? Equals 2 into delta L over L into 100%. This is the percentage error of area. Pay attention. And the percentage error of area is given as 2%. Percentage error of area is given as 2%. Clear? You divide both sides by 2. You get delta L over L into 100%. You get delta L over L into 100%. Delta L over L into 100% equals what? 1%. You divide both sides by 2. Then you get delta L over L into 100% equals 1%. Clear? Now, to get the percentage error for volume, you need delta V over V into 100%. To get the percentage of volume, you need delta V over V into 100%. That means 3 into delta over L into 100%. 3 into delta L over L into 100%. What is delta L over L into 100%? It is 1%. Delta L over L into 100% is 1%. So you get 3 into 1%, which gives you 3%. Okay. This is 3%. Clear? Okay. You get 3%. Okay. Percentage of area is given as 2%. Then what is the percentage of volume? So there's a lot of cheats about when is Aurudu, when is the event. Yeah, ideally it's going to be a Tuesday. I think that this month some kind of a Tuesday. The problem is if it most probably it will be a Tuesday within this month, towards the end of the month, because can't affect all the other classes. That is the problem. That means not my one, the other classes of the other subjects and all. So we'll let you know. Within this week, we'll let you know. And still we haven't figured out whether it's our Urdu or a match or what. But no point of just playing a cricket match, right? None of you guys are good at cricket, right? People who are good at cricket? People who are good at cricket, see, we have a few. We can't even make a team with this number. Still, I got like 6. What about others? If the one next to you is good at cricket, still no. See, and now we have like one team. So you see. Oh, you are good at watching cricket, yeah. So would be in this month, okay? Yes, ideally would be in this month. We'll inform within this week. So pay attention. Pay attention. So today, pay attention. Today we are starting that extra session from 6:30 to 7:30 to discuss difficult and fast content. Difficult and fast content. But the thing is, at the moment, we don't have a lot of physics to do there. So we may have to do some physics plus maths. Okay? We don't have a lot of physics to do at the moment. But with time, after like 3-4 weeks, we can entirely do physics in the 6:30, 7:30 time slot too. Entirely physics and everything in the syllabus. But would be very difficult content. That is the target. Pay attention. We have to focus on extremely difficult content too. But the thing is, again I repeat, if you don't understand something happening in the 6:30, 7:30 time slot, don't worry about that, okay? Don't worry about that. That's the whole point of doing a separate session for that. Then you can not understand but feel okay about that and try to grow. That is the time, that is the purpose of that additional time. Later we'll try to arrange an additional day as soon as possible for these two. An additional day entirely to do extremely difficult, fast content with difficult questions, totally focusing on improving your intelligence, okay? When we start that session, again, you don't have to worry about not understanding them. It's all about improving. That's all. So again, today, you can stay for the session or leave. It's okay. But try to watch the recording. But when you're watching the recording, pay attention. When you're watching the recording, don't try to watch the recording again and again and again and understand. Or don't try to slow down the recording and understand. Doing that session, 6:30, 7:30 session at a fast rate is the whole purpose of that. Then you later try to understand things fast. Today you may not understand anything, but by next week your thinking speed may improve a bit. So if you go home and slow down and watch the recording. The whole purpose is destroyed, okay? So you may understand or you may not. Still, if you watch the recording, just watch it at the normal speed. You will understand. If you understand, you will understand or not. It's okay. That's the whole point of that session. We do a series of very difficult, fast questions with the hope of understanding them someday, okay? That is the whole point, okay? So, yeah. So, feel free to leave now. I'm directly starting the session, okay? And in the middle also you can leave. That means if you can stay until 7, stay until 7 and go. It's okay, okay? Just you don't have to inform me. Just you can stand up and go. Because many students may have transport issues kind of stuff. You can watch the recording, okay? You can watch the recording. I'll provide that in the group. Others can stay. The students who need to leave can leave. And if you need to stay until 7 and leave due to transport issues, it's okay. You don't have to inform me. Leave at 7, okay? I'm going to start the session. Okay? It's an entirely additional one. Yes, if you like, take a separate book. And if you have any questions, you can come here and discuss with me, okay? It's okay, even though we start a session, you can come here and discuss with me if you have any questions. And if you need any additional details to be added to the group or anything else, you can work with our invigilators. So if you have any issues or anything to be asked, you can come here and I'll explain. Okay. If anyone have questions, you can come here and ask, okay? Okay, so let's start. Pay attention. Let's start. So today, the main purpose of today's session is clarifying whatever the doubts we have had in previous weeks, okay? Clarifying whatever the doubts we had in previous weeks. Previous weeks in the sense, on the first day, pay attention. On the first day, we gave a separate tute with difficult questions. We didn't discuss that. So we have to first finish that. We have to first finish those content, okay? We first have to finish those content, then move forward, okay? Okay. Go to Olympiad questions. There's a tute called Olympiad questions. These are not actually Olympiad. In the future, you will see actual Olympiad questions. So, Mali, provide that drive link again in the Zoom chat and in the YouTube live chat. In the YouTube live chat, you can find the drive link with that tute. In the groups, you can find a separate channel for the tutes, okay? In the group, you can find a separate channel for the tutes. You can join that channel and get the tutes. And in the Zoom chat also, you can find a drive link where you can get the tutes. And even in the resources section of the webinar, from the resources section of the webinar, you can get tutes, okay? Okay. So let's move forward. So question 1 we discussed in the class. Question 1 we discussed in the class, right? It was the first question of that tute. Question 2, log 10, this is not a difficult question. 2x minus 5, log 10, 2x minus 5 equals 1. Find x. Pay attention now. Log 10, 2x minus 5 equals 1. Find the value of x. So you get log 10, 2x minus 5 equals log 10, 10, right? 1 means log 10 and 10 here, right? Clear? Okay, that's how you get 1. So that means this is log 10, this is log 10, that means this is equal to this. So 2x minus 5 equals 10. So 2x equals 15 and x equals 7.5, right? X equals 7.5. Then let's go to question 3. You can watch the recording and write things later. If you can write really fast with me, you can write. Otherwise, online students, you can get screenshots. And physical students, you can get the recording and write them, okay? You can get the recording and write them. So I can't wait until you write. So I'll do something like this. We'll every day after the session, we'll get the screenshots from the recording and put them on the group, okay? Then you can focus on listening. If possible, you can write. Otherwise, you can just focus on listening. Later, go home and write, okay? So every week, we'll take from our side, we'll take the screenshots of the recording and we'll put that in the group. So later, you can focus on writing later, okay? If you have time, yes, you write, do write. Otherwise, it's okay not to write. We'll arrange that from our side because I can't wait until you write. 3. This is the system given. I'm going to skip some questions. We may use this tute for this week and next week. I'm going to skip some questions and do them next week. Okay. So the question is, find the area of the circle. Distance of this side is 3. Distance of this side is 4. And the distance of this side is 5. Distance of this side is 5. Okay. Then I can find the area of the circle. I can find the area of the circle if I can find the radius, right? So there's a definite symmetry in the system that I can use, right? That means here, this is the radius. This is the radius. And again, this is the radius. This is 90 degrees. This is 90 degrees, right? Again, this is the radius. This is 90 degrees. Clear? So now, I can use the vertical and horizontal paths to come up with the answer. How? What is this length? And symmetric nature I can use. What is this length? If this is 3 and if this is r, if this is 3 and if this is r, this is 3 minus r. If this is 4 and if this part is r, this is going to be 4 minus r. And you should see the symmetric nature of the system. See, this part here, 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 and here. This part is symmetric, right? This part is symmetric, right? Clear? This part is symmetric. So if this is 3 minus r, again, this is going to be 3 minus r. If this part is 3 minus r, this part is 3 minus r. Clear? And again, this one is symmetric too. This, and this. this is symmetric too. So if this is 4 minus r, again this is going to be 4 minus r. If this is 4 minus r, this length would be 4 minus r again, right? Because this part, it is symmetric. Clear? It is symmetric. Okay. So now I have the answer, right? Why? See this length? See this length? It is 5. That length is 5. This length is 5. And it is equal to 3 minus r plus 4 minus r. This 5 is equal to 3 minus r plus 4 minus r, right? Clear? Then you are going to get what? 5 equals 7 minus 2r. Then 2r equals 2. 2r equals 2. Then r equals 1. R equals 1. Now you know the area, right? Pi means 3.14 and r is 1 squared. So this is the area. Clear? Something like question 4 did we discuss in the class? Root 5, root 5, root 5, root 5. Yes or no? Yes? Oh no? 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 I'll quickly go through that because I can remember like I did something. Root 5, root 5, root 5, root 5. This is going to go until infinity, okay? This is going to go until infinity. Clear? This is going to go till infinity. So we need to find the value of this. So let's take the value of this as x. Let's get the value of this as x. And there's infinite number of root 5s. Okay? And the thing is, pay attention. And the thing is, like, infinity minus 1 is still infinity, right? Infinity minus 1 is still infinity. Okay? That's the nature of infinity, okay? So, infinity minus 1 is infinity. So, if you just remove one layer from this, still this part will not change, right? The answer will not change. Okay? Why? If you have a bunch of papers, infinite number of papers, if you remove one paper, still the height is going to be infinity, right? If you have an infinite number of papers, you just remove one paper from that stack, still it's infinity, right? Okay, infinity will not be affected by 1. Okay, so you have infinite layers of root 5s. So you just remove one layer, okay? You just remove one layer. So if the full answer is x, if you remove one layer, still this part is going to be x, right? If you remove one layer out of that, still this part is going to be x. Clear? That's the nature of infinity, okay? So you can write x equals here root 5 and this part you can still write as x, okay? This part you can still write as x. Clear? Then you get the square of both sides. Then you get x squared equals 5x. You can cancel out x. X is not 0, by the way. X is not 0. X can't be 0. Clear? X can't be 0. You cancel out x. Then you get what? X equals 5. X equals 5. Clear? Okay? And I think even as I remember, I did something like this, but I didn't explain you the reason to do this kind of stuff, right? Didn't I show you an infinite resistor network? No? I mean, the reason is, so you will never get a question like this in A-level physics paper, okay? For sure. This is not physics, this is maths, okay? You will never get a question like this in A-level physics paper. But in the A-level physics paper, 1 year, they asked a question like this. 1 year in A-level physics paper, MCQ, they asked a question like this. You know resistor networks. You know resistor networks like this. They said that there's a resistor network that goes like this until infinity. They said that there's a resistor network that goes until infinity. Clear? Clear? A resistor network that goes until infinity in A levels, okay? Then they ask you to find the resultant resistance here. You won't be able to solve this now because we have a separate current electricity lesson, okay? We have a separate current electricity lesson. Then you will be able to solve this, but not this. Because even in the current electricity lesson, we learn how to solve like finite resistor systems, not an infinite network. What they are telling is this goes until infinity. Clear? Okay. So no one was able to like handle this kind of stuff. But I mean, anyone who have done this kind of a question, okay, anyone who have done this kind of a question would have a clue about this, right? Anyone who has done this kind of a question would have a clue like about this, right? So if the resultant of this whole network is R dash, if the resultant of this whole network is R dash, okay, you just remove one loop from that. This part you remove. Still this side can be considered as R dash, right? Clear? Still this part, without this part, still this side will be R dash, right? Clear? That's how the infinity works. You have infinite number of these stuff. You just remove one part of that. Won't make any change, okay? It won't make any change to the system, okay? Clear? It won't affect the system, clear? So what? So, you have R here, and R here. And the resultant of this is R dash, and even the part after this. That was the part that it was difficult to analyze. Why? There's like infinite number of resistors. How can I solve that? But that whole part you can again write as R dash. Then you write an equation, solve for R dash. Okay. So, I mean, you won't be able to handle this either because you haven't done current electricity lesson. But that's the whole point of doing these things like this, okay? Because it's not maths or physics. Concepts are concepts, okay? How infinity works is a concept, okay? So that's, I mean, it's not, we can't just classify these stuff as, okay, these are maths, this is maths, I don't need these stuff. No, it's not like that, okay? Concepts are concepts. How infinity works, it's same in physics, it's same in maths. So that's why we are developing concepts here, okay? We are not doing just a bunch of maths questions in a physics class. Okay, would feel useless, okay? You would feel like this is useless. Why? Why the hell are we doing a bunch of maths questions in a physics class? No, we are developing concepts on how to see things, okay? How to see things. This is from A levels. This is directly from A levels. So only a person who have seen a question like this in their lifetime would have a clue about that question, okay? Otherwise, no one would be able to handle a question like this. Clear? That's the whole point of doing some maths, okay? Especially for bio people, okay? You can't get rid of maths. I mean, usually, like, if you ask from bio people, usually they like to be doctors. And if you ask from maths people, why they did maths, they just don't like to study. That's how things usually happen. I have asked the question from many people. Bio people, they like to move forward in bio. Yeah, they like to be doctors. If you ask why are you doing maths from a maths guy, I don't like to study. That's why I'm not doing bio. Just I mean, I have tested that with many students. It always happens. So, I mean, bio people, you can't get rid of maths, okay? You can't get rid of maths either. Question 6. Question 6. Radius of a circle is r. Radius of a circle is r. We need to measure the length of this belt. We need to measure the belt of this length. So again, let's break down the question. There's a simple part that I can find. There's a simple part that I can find. This part I can easily find. This length I can easily find, the linear part. Okay, and if you can't find the entire answer, okay, if you can find the final answer, just just work with the part that you can handle, right? That means this part you can find, right? The straight line part. Why? This is r, this is r, this is r, this is r. So it's going to be 4r, right? This length is equal to this length. See? This length is equal to this length. This is r plus r plus r plus r, which is 4r. Clear? So that straight line parts are easy to find, okay? The straight line paths are easy to find. Okay? Those linear paths are easy to find. It's 4r. And again, 4r here. So now a large part of the question is over. Now I have to find this part only, this circular part only. I have to find this circular part only. Clear? Clear? Again, it's not that difficult. If we find the angles in the sense, see, this is a straight line. This is a straight line. And this is parallel. So this part is 90 degrees then. Again, this part is 90 degrees. Clear? This part is 90 degrees and this part is 90 degrees. And this is 60, right? This is 60. Why? See? The sides of this triangle is equal. See? Sides of this triangle is equal. See? So it's going to be 60, 60 and 60, right? It's going to be 60, 60 and 60. So what is this angle then? Theta. What is this theta then? I can write full circle means 360. Full circle means 360. It is equal to 90 plus 90 plus 90 plus 90 plus 60 plus theta. Full circle means 360 equals 90 plus 90 plus 60 plus theta. Then theta would be 120, right? Theta would be 120. Okay. Then what is the length of this circular path? Length of this circular part would be, length of that circular part would be, one full circle means 2 pi r. One full circle means 2 pi r. One full circle means 2 pi r. And 2 pi r is for 360 degrees. One full circle. Length 2 pi r is for 360 degrees. One full circle. Then how much for 120 degrees? Clear? Then how much for 120 degrees. Clear? How much will belong to 120 degrees? Clear? 120 degrees. So we get 2 pi r, here 2 over 3, right? Sorry, it's just 3. 2 pi r over 3. This and this cancel out, I get 2 pi r over 3. So what is the total length of the belt? Total length of the belt is 4r, 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 which means 12r. 4r, 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 which means 12r, plus this. That means it is 2 pi r over 3 into 3, right? 3 pieces like that. 3 pieces like that. Clear? It's 3 pieces of this. Clear? Then 3 cancels out. We get 12r plus 2 pi r. We get 12r plus 2 pi r. Okay. Question 7 you can try at home. I'll do that next week. Question 7. Try to do, since we handled some questions like this, now you can try to do question 7. You may need some extra diagrams on that, but try question 7. Let's go to 8. Let's go to 8. I missed the 5th one. What is the 5th one? Oh, 5th one we did, right? 5th question again we did in the second day or something like that, right? Question 5 we did in the class. That's why I skipped that. We did that on the second day of the class, as I remember. Question 8. There's a frog. Jump a distance of x first. Pay attention, stop talking. Pay attention. A frog jumped a distance of x first, then x over 3, then x over 9, then x over 27, like this. So what is the total distance jumped by the frog? Let's take the total distance should be, keep adding these stuff, and it's again going until infinity, okay? It's again going until infinity. So a possible mechanics question, okay? It's gonna go until infinity. So there are 2 ways that you can solve this, I think. This is a geometric progression, right? We call them geometric progressions, right? 1 over 3, 1 over 3 squared, 1 over 3 cube. This is geometric progression, right? And if you write the next term, it's going to be x over 81, I think. It's going to keep going until like that. Pay attention. And you know how to solve a geometric progression, right? You know the sum of a geometric progression, I think. You know how to get the sum of a geometric progression, right? Was in O levels or O levels, right? Okay. But you don't know how to get the sum of infinite terms, right? That is the problem. You don't know how to get the sum of infinite terms. For that, you just use n number of terms and make n infinity later. It's a different story. I'll do that next week. I'll do geometric progressions stuff next week with some other questions. So today, since we learned the properties of infinity, let's try to solve the question without a geometric progression. Because without a geometric progression, I think we can handle the question, because we just learned the properties of infinity, right? So I think we would be able to handle this without a geometric progression. How? Let's divide the whole term by x. P of x, you get what? 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 81 plus, like this. Pay attention. So now, let's do something like this. P of x equals 1 plus, let's take this part. Let's take this part. I'll move 1 over 3 out from that. I'll move 1 over 3 out from these terms, okay? When I move 1 over 3 out from these terms, this one becomes 1. This one becomes 1 over 3. This one becomes 1 over 9. This one becomes 1 over 27. Like that, I get again a 1000 number of terms. Clear? I just took a common 1 over 3 out from these terms. Clear? Now the best thing is, see, P of x means 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 81 until infinity. See here, what do I get? Again 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 until infinity. So if this is P of x, this is also P of x, right? If this is P of x, clear? This is again P of x, right? Same term, right? So I can write P of x equals 1 plus 1 over 3. This term is again P of x. Clear? Then let's take this to this side. P of x minus 1 over 3 P of x equals 1. Then we get P of x common. 1 minus 1 over 3. 1 minus 1 over 3 equals 1. Then we get P of x equal into, you solve this, you get 2 over 3 equals 1. Then you get P over x equals 3 over 2. Then P equals 3x over 2. P equals 3x over 2. Okay. So like within 3-4 weeks, this tute will be entirely physics, okay? And entirely in syllabus. Still we don't have a lot of stuff to do in the syllabus. That's the problem. I think we did question 9 and 10, right? 10 for sure we did. Question 9? Did we do that in the class? Question 9? Yes, right? Yes, 9 and 10 we did in the class. 9 and 10. That you try. Try that. I'm going to discuss question 7 next week. I'm going to discuss question 7 next week. It wasn't discussed in the class, but I need you to try. It's difficult a bit, I think. Next. Question 11. This was there in the last week's paper. Some students asked this. That's why I included this in the tute. Okay. Some students asked this question 11. That's why I included it in the tute. If fundamental units of mass and length are increased by a factor of 3, that becomes m becomes 3m, L becomes 3L. By what factor will the derived unit of energy change. So what is the derived unit of energy? M L squared T minus 2. Derived unit of energy is ml squared T minus 2 using dimensions, right? So M becomes 3m, M becomes 3m and L becomes 3L. T minus 2. T isn't changing. M becomes 3m and L becomes 3L. Clear? Then we get what? Here 3 and here 3 squared m L squared T minus 2 and you get what? 27. So energy becomes 27 times. Energy becomes 27 times. Okay. Question 12. Question 12. Energy becomes 27 times. For the frog question, it says very long time. Does that mean it's infinity? Yes, nothing else, right? I mean, very long in the sense, yes, I mean, they haven't given us a limit. They haven't mentioned a limit. A very long time means they haven't mentioned a limit. That means an infinite time. Okay. Next one. Next one. Question 12. Question 12. Consider a hypothetical unit system in which mass and energy are dimensionless. So, pay attention. There's a hypothetical unit system, mass is dimensionless. That means in this unit system, m is 1 and energy is dimensionless. That means m L squared T minus 2, again it's dimensionless. Energy is dimensionless. M L squared T minus 2 is energy. It is dimensionless. Clear? And m is already dimensionless. So 1 into L squared T minus 2 equals 1. Okay? So you can write L squared equals 1 over T minus 2, which means T squared. Which means T squared. You take this T minus 2 here, you take that up. So L squared equals T squared means L equals T. So I just tried, I just understood the unit system a bit more. So, what they have actually mentioned is, m is 1 and L is equal to T in your new unit system. Okay? M is 1 and L is equal to T. Clear? That's what they have actually mentioned about the new unit system. Okay? Now what can you do? Focus on listening, okay? You don't have to focus on writing. These are actually concepts on how to think. So, it need not to be in a tute or a note, okay? These, all these questions, even the questions we are doing in the upcoming weeks, it's not about what you write. It's about the concept you develop on the spot, okay? You get a feeling about, you understand that you can even think like that. You see a possibility. You see a possibility that you didn't see before. Then there's a tendency of you trying to think that way the next time. Then when it keeps happening, after a while you actually do that, okay? Clear? That is the target. So it's not about writing, okay? So don't worry about writing. Don't miss anything just for the sake of writing. It's not about writing. You develop some kind of a sense of a possibility of a new way of thinking on the spot, okay? You develop a new way of thinking on the spot. That over a period of time, that helps you change the way you think, okay? So it's not about what you write, okay? You don't have to study these things. You don't even have to see these things ever again, okay? You see something now, you develop a concept or sense about how to think in a different way on the spot. That's all. That's what we need, okay? So it's about developing the brain, not filling your knot, okay? So forget writing. If you can write real time, then okay. Otherwise, don't miss anything for the sake of writing, okay? Writing have nothing to do here, okay? Next. So this is the system. And many of these questions are not the kind of question you can like not listen for like 1 minute to write, then you can return and understand. No, then you understand nothing, okay? So keep listening. Okay, so M is 1 and energy is 1. So when I solve this, I get L equals T. I get L equals T. Okay, pay attention. Now let's check. The dimensions of force is L minus 1. So what is the usual dimension of force? Usual dimension of force is MLT minus 2, right? Usual dimension of force is MLT minus 2. And in this system, M is 1. M is 1. L is L. And T is also L, right? T is also L. So T minus 2 can be written as L minus 2. T minus 2 can be written as L minus 2 in my new unit system, right? And when you solve this, you get L minus 1 actually. Clear? You get L minus 1. So it's correct. It's correct. You are getting? First one is correct. Dimensions of force is correct. A is correct. B. Dimension of momentum. Momentum means momentum. The dimensions of momentum means mass into velocity, right? Momentum means, pay attention, stop talking. Momentum is mass into velocity. Mass into velocity. That means M L T minus 1. Momentum is MLT minus 1. So the mass is what? Mass is dimensionless 1 in this new system. Mass is 1. Mass is 1. And L is T. See, L is T. So you can write T here and you have T minus here. So they cancel out and you get 1 again. Okay, so this is L, this is momentum. Okay, I'll just use some kind of a symbol for that P. Okay, 1. So B is not correct. Okay, momentum is 1 again. Momentum becomes dimensionless in our new unit system. Clear? Momentum becomes dimensionless in our new unit system. Clear? So B is not a correct answer. C. The dimension of pressure. So again, pressure, let's take as again B. Pressure, dimensions of pressure is ml minus 1 T minus 2, right? Dimensions of pressure is ml minus 1 T minus 2. Okay. You can get these from the last page of your tute, the dimensions of unknowns. And M is 1 in our new unit system. Here you have L minus 1. And T is equal to L in our new unit system, right? See? L equals T in our new unit system. Clear? L equals T. So I can replace T by L. Then I get L minus 2. Then altogether I get L minus 3. Altogether I get L minus 3. And the problem is there's no L minus 3 here. So C is again wrong. So the only correct answer is A. Only correct answer is A. Let's try question 13. You need the additional hard questions book, right? Just put a message to our invigilators numbers. They will send you the additional hard questions book. This PDF you can get the resources section of the webinar. You can get the from the resources section of the webinar. Okay. Question 13. Question 13. Square root 9 minus root 8. Pay attention. Root 9 minus root 8. And they have given me root 2 equals 1.41. So the idea is this. Pay attention. Pay attention. If they are giving me the value of root 2 is 1.41, that means they are expecting us to convert everything into one root 2 terms, right? Then only we can solve this, right? They are only giving me the value of root 2 as 1.41. When we see the question, we should see the target. They are expecting us to convert everything into root 2 terms, right? Okay. So let's solve this to the maximum extent first. Before thinking, there are some areas that you can solve easily on your level. First finish them. Like what? Root 3 you know, right? Root 9 you know, right? What is root 9? Root 9 is 3. Clear? And what is root 8? What is root 8? Root 8 is 2 into 4. And you can get 4 out as 2. Then it becomes 2 root 2, right? You can get 4 out. Pay attention. You can get 4 out as 2. Then it becomes 2 root 2. Clear? Now what? So 8 can be written as 2 root 2. So now you have the answer. When you see 3, 2 root 2, you should be able to solve this. How? You can write this as 2 minus 2 root 2 plus 1, right? 2 minus 2 root 2 plus 1, right? Why? 3 equals 2 plus 1. 3 equals 2 plus 1 minus 2 root 2. 3 equals 2 plus 1 minus 2 root 2. Clear? Now what? What is 2? 2 is root 2 squared minus 2 root 2 plus 1. What is this? What is this? This is, I think, root 2 minus 1 squared, right? This is root 2 minus 1 squared, right? See, what is root 2 minus 1 squared? Root 2 squared minus 2 into root 2 into 1, then 1 squared, that means 1. See? Clear? Clear? So this is root 2 minus 1 squared. So now what? Pay attention, stop talking. Pay attention. So this is root 2 minus 1 squared, and square root of that gives you what? Root 2 minus 1. Clear? Square root of that gives you root 2 minus 1. Root 2 minus 1 squared, and square root of that gives you root 2 minus 1, which means root 2 is 1.41 minus 1 equals 0.41. Equals 0.41. Okay. And Question 15, definite. Anyone got answers for question 15? Pay attention. Anyone got answers for question 15? No? No? Anyone tried question 15? Try that for sure. Okay, it's a nice motion graphs question. Yes, we haven't done motion graphs in mechanics set, in A-level set. But I mean, you did motion graphs in O-levels, right? Clear? You had some motion graphs in O-levels, right? A displacement time graph and a distance time graph you can handle, right? So try that. Try question 15. It's a nice question. Should I discuss 15 today or you're going to try this? You better try that. Yeah. Try question 15. It's a nice question. And pay attention. In question 15, pay attention. In question 15, what they are doing is they are graphing the gap. They are always graphing the graph is about the gap of two vehicles, okay? In question 15, graph is about the gap between two vehicles, okay? Clear? The graph shows the gap between the two vehicles throughout the time, okay? Graph shows the gap between two vehicles throughout the time, okay? Try that. So with the time we have today, let's try 14 then. Let's try 14. 14 means 4 to the power x plus 6 to the power x. So pay attention. So some questions like this are not entirely necessary for physics, okay? Things like this are not entirely necessary for physics. It's there because, I mean, we don't have enough physics question at the moment, okay? We haven't done enough physics questions to go with difficult questions. That's why these kind of stuff. Otherwise, these kind of stuff are not necessary for physics actually. This, not others, this. Not other questions. This is not necessary for physics actually. We can try, yeah, we can, I mean, try different methods for this, okay? We can try different methods for this. But I can first try, this is 2 squared. I mean, I'll try to solve what I know, okay? This is 2 squared. This is still I can keep it as 6. This is 3 squared. This is 3 squared, right? Pay attention. I can start like this. Then I can divide the system. I mean, this is actually 2 into 2x plus this is actually 2 into 3 into x. That means 2x and 3x, right? Pay attention. Pay attention. This means 2 into 3 into x. That means this is 2 dot 3x, which means 2x dot 3x, right? Clear? So we can write this as 2x dot 3x, and this is equal to 3 into 2x. I'll tell you a method and you can try this at home. Let's try to do something like this. Let's divide the whole equation by 3 to the power 2x. Then you get 2 to the power 2x over 3 to the power 2x plus 2 to the power x, 3 to the power x over 3 to the power 2x equals 1. Then you can get 2 over 3, pay attention, to the power 2x plus, here this 3 to the power x and this will cancel out. Clear? 3 to the power x and 3 to the power 2x will cancel out and you are left with 3 to the power x. 3 to the power x and 3 to the power 2x cancel out, then you are left with 3 to the power x. Then you get 2 to the power x over 3 to the power x, which means 2 over 3 to the power x equals 1. And next, this is actually what? It is 2 to the power 3. It is 2 to the power 3x and squared of it, right? 2x means 2 to the power 3x squared. This is 2 to the power 3x squared. And this is, pay attention, this is 2 to the power 3x equals 1. Pay attention, stop talking. Clear? Then, now you have an answer, right? Why? You can find 2 to the power 3x. How? Just consider 2 to the power 3x as a. Then you have a squared plus a equals 1. So, do we know how to solve this? A squared plus a minus 1 equals 0. A squared plus a minus 1 equals 0. Do you know how to solve something like this? There's no direct answer, right? Then you have an equation. Can you remember? Minus a plus o minus b squared minus 4ac over 2a. Had something like this, right? Yes, right? This was in O levels, right? Sorry, minus a, I can read minus b, right? Yeah, minus b plus o minus b squared minus 4ac over 2a, right? Now it's correct, right? You just apply that and get the answer, okay? That means minus b means minus 1 plus o minus, pay attention, b squared means 1 squared minus 4, a is 1, c is minus 1, a is 1, c is minus 1 over 2 into, again a is 1. Can you remember? So what do we get here? Minus 1 plus o minus 3, right? Root 3, right? Root 5 minus plus over 2. So this is the answer for A. This is the answer for A here, right? Clear? Can you remember? This is the answer for A. So that means you know the answer for 2 over 3 to the power x. You know the answer 2 over 3 to the power x. Clear? Now you get log and solve, right? You get log and solve. How can you get log? How can you solve this by taking log? You take log of both sides. Pay attention. You take log of both sides. Log minus 1 plus o minus root 5 over 2 equals log, pay attention, equals log 2 over 3 to the power x. So can you remember you can write this x here? Can you remember you can write this x here? You can take this x here. Then it becomes x log 2 over 3. So x becomes this log minus 1 plus o minus root 5 over 2 divided by this log 2 over 3. So we didn't have enough time. That's why I moved through this question a bit fast. So this is not actually necessary. This is too much. This is maths. You won't get this kind of stuff in physics. For maths people, you are going to get like 1,000 times difficult stuff. But this is okay. This is not necessary. Everything else is necessary. This is too much maths. This is not need. Okay, for maths people, you need this. For bio people, you don't need this. Forget this. Okay. So try the tute if possible. Let's meet next week. That's all. No other news. Try to finish like at least one question if possible. Yes, actually. Yeah, they are actually noisy.